This conference will now be recorded.
So before we start, let me start off with a brief introduction of myself. I'm Srinivas. I'm the founder of the institute. I handle the front-end domain activities, that is RTL design, RTL verification, RTL integration, so all those aspects. So I have started my career in 2005, and since 2009 till 2019, I was working. So after that, I'm full time into training. Even before that, I was teaching, but since 2019, I'm full time into training. Other than institute training, I also do corporate trainings to the companies. Okay. Now let's come back to the today's training session. So today, as you are aware, we'll be doing the demo session for VLSI front-end domain. So when we say VLSI front-end domain, we are not only talking about design verification. So we'll touch upon what is uh, RTL design, what is RTL integration, what is RTL verification. Our major focus in today's demo session will be to understand how our course will be structured to make it more relevant for the upcoming job requirements. See, what was 1 year back is different. Now, what is the scenario now is different, because now the requirement is for getting ourselves prepared for the AI specific job requirements. I mean, how to work along with AI. Now, you may have doubts: will how many jobs will be there? What will be the job scenario and all that? And by now, you'd have got a fair idea that complete replacement won't happen. Means there was a talk at one point, a lot of jobs will be impacted and there won't be any jobs. That kind of talk. Now, after trying all the things, see the companies, a lot of companies have been trying, right? Product companies. If you talk about our VLSI domain, it could be Qualcomm, Intel, Nvidia. So I don't want to name any particular company. So thing is, the AI is not able to do complete things, and the cost factor comes in. You might have heard the token cost, all that. So we'll touch upon all those things. I don't want to just start off randomly with something. So our session also will be focused on two aspects. One is to understand how our course will be structured, completely structured to make it relevant for AI specific job requirements. Second is and how will be the job scenario considering the AI impact and all that. Okay, and what is that you should be doing is also will be touching upon. Okay, so first let me just give you a brief about what is the today's session agenda. So we'll first start off with understanding what all courses are starting. I mean, we are starting a batch this week. So what all courses we are starting, we'll touch upon that. We'll discuss on that. Brief overview of the institute. And first, then we'll start off with understanding the electronic system. What exactly is VLSI? What is embedded system? How do they interface? Just to get an understanding about what all different layers are there in electronic systems and how they interface with each other. Then we'll understand the VLSI design, and in that context, we will also discuss about what is ASIC, what is FPGA, a brief about that. Then we'll touch upon VLSI design flow, where we'll talk about the front-end domain flow and the back-end domain flow. And we'll talk about in the VLSI domain what all job roles are there. Yeah. Okay. Whether it be in the front end domain, whether it be in the back end domain, what are the different job roles? Then we'll also talk about what is the skill set required for each of these job roles. Let's say if you want to get into front end domain, many of you would be from electronics domain, right? Uh, Whenever you have selected this design verification, one fear factor will be there about how about coding. I mean, I'm not good with coding, I haven't done any coding before, so can I cope up with this? Now, as you see, with the evolution of AI and AI agents, you don't have to do a lot of coding, very minimal coding you have to do. We have to understand the concepts, how the things work. Okay, whether the whatever agents are doing, let's say it's like you sit with an agent. The agent can be from a Claude, it can be from OpenAI, it can be from Gemini. There are cursor, there are many things are coming up, right? So you can be sitting with any agent. You have to make sure that he is doing the work properly. You have to give the instructions to him. How do you give instruction? By means of prompt. So you have to get used to that style of working. As an institute also, we have to evolve. I mean, I cannot be teaching the same 5-year-old syllabus where teach with digital Verilog. I mean, that of course has to be part of it, where we have to teach the fundamentals, but our course will definitely is evolving, where we will be teaching AI related things. I mean, we'll be making sure that you are prepared to work with agents. If you go to job any company, they'll give you agents. Agents means tokens. Okay, you will be asked to inform, make the agent do the work for you. So we'll also try to inculcate that kind of work culture, I mean working process in the institute flow. Okay. But that I cannot do from day one, right? First I have to start with the fundamentals. Okay. So that is what I was talking about, skill set. Probably 2 years back or 1 year back when I was doing demo, we never talked about this manner, because that time agents and all was a very new concept, new thing, and it wasn't even in the full-fledged implementation. Okay. Next, how to choose the right domain. Then what all facilities that are offered by institute and how to prepare for job, and why career in VLSI. And then we'll talk briefly about placements, and finally we'll go for any question and answers. So this is a brief overview of agenda. Okay, I have already just told about myself. Okay, now let's talk about what all courses starting today. Okay. You see, we divide the entire all the courses into two categories. One is the front end domain courses, one is the back end domain courses. In software, if you take, there are majorly three job roles will be there. One is an architect who architects the software. The second category is the person who develops the software. Third person is the person who does the testing of the software. You have architect, you have a developer, you have a tester. So there I mean, your selection process is pretty simple. In either you want to get into developer role, or either you want to get into tester role, right? Coming to VLSI, thing is we don't have like three roles. We have almost 15 job roles are there. In VLSI, a person can get into 15 different types of activities. A person can become a RTL design engineer, RTL integration engineer, RTL verification engineer. Person can become physical design engineer, DFT engineer. Now, point is, do I need to learn everything? No need. Even whatever career I had, let's say 14, 15 years of work experience I had, I never learned anything beyond my scope of domain. My domain was functional verification. I never learned anything related to physical design. I never learned anything related to DFT or anything. So first thing, you have to come out of that fear factor that VLSI is difficult. It's not difficult. You just have to give that dedicated 6 to 8 months time to gain expertise in one domain. You choose one domain. That domain can be physical design. That domain can be DFT. That domain can be functional verification. Any domain, particular domain you choose, and you try to become expert in that domain. So in that context, since there are many domains are there, totally how many I said? Around 15 domains. We cannot have a demo for each domain, right? It's difficult. So what we have done is, we have majorly divided all these domains into two categories. One is the front end specific domains, other is the back end specific domains. So today will be the demo session for the domains focused on front end specific domains. So what all courses fall into front end domain? Let's quickly go over that. One is the RTL design and functional verification. In that, we have another course called as front end training for freshers, design verification course, functional verification training for freshers, ASIC verification. When I say any of them, all of them are referring to the same course. Whether I call front end domain training, whether I call design and verification training, whether I call functional verification training, in the institute perspective, all courses are same, because we are going to teach you the basics of RTL design also, and we will also teach you in depth of functional verification also. Both will be covered. So in that context, whatever name you refer, either you refer by any of these names, we are going to do the same course. Rather, I should say AI integrated course, because we have a dedicated track that will run for AI. I mean, every Saturday we have some Python class and AI focused session which will be covered specific to AI. Next, the another course that is starting today is the same verification training for experienced engineers. Many times people working in the industry also have few things to learn. I mean, it's not that they are expert with everything. Even while they are working, there are some gaps they will have. It could be the gaps with the system Verilog, it could be their learning gap with UVM, or it could be the exposure to the projects. So to address those gaps, we have a course for experienced engineers as well. Then we have a course on Verilog for design verification, system Verilog for functional verification. So what are these courses is, these are meant for students who are currently pursuing their BTech. I mean, someone might be in BTech third year or fourth year. So they want to do some short-term courses. So for them, we give this opportunity to pursue the courses here. While they are doing BTech, they can join these short-term courses. So even today, we are starting with that course as well. Other than that, today we are also starting a course on FPGA design and verification. Rather, I will call FPGA system design. So in the today's session, we'll talk about what is ASIC, what is FPGA. So one of the other domain is FPGA. So even that course is starting today. Other than that, we are also starting course on RTL design and integration. DFT, today we have a even DFT demo session in the post lunch. I mean, but even if you are from DFT domain, some of you can still attend this session, because some of the things we are going to talk for initial 1.5 hour will be relevant for most of you. But for the DFT specific demo session will be at 2:30, where the trainer will talk about what we are going to cover as part of the DFT flow, everything. So this is a brief about what all courses we are starting today. I have already given you a reason why we are doing so many sessions today. We have almost 15 domains that we can teach, we can do in VLSI. So we cannot have each day for one demo. So I have to spend 15 demo sessions. So rather, we kind of majorly classified as front-end training, front-end specific demo session. Tomorrow will be the back-end specific demo session, where we focus on physical design, layout, synthesis and STA, those kind of things. Now, as you know, the demo session is from 9:30 to around 12:30, and the DFT demo session will be at 2:30 p.m. today. Okay. So this is a brief about what all courses we are starting today. Now let's get into the today's training agenda. The first topic we want to talk is understanding of electronic systems. So before I go into the slides further, let me just give you a brief about what is that we are trying to do. Okay. So if you take an example of a mobile phone, okay, what all layers do you think it has got? I mean, what is it? Just the hardware are we talking about? To talk about this mobile phone, are we just talking about the hardware? No, right? Other than hardware is what we are seeing, right? Uh, Nandan, our team will inform you. Mostly, it should be the same link, but our admin team will inform you what will be the DFT demo session link. So as I was we are discussing about a mobile phone. So we are trying to understand what constitutes an electronic system. Let's assume this is an electronic system. Do you think is it the only hardware that makes this work? No, right? What else do you think goes into this mobile phone because of which it is working? So this consists of hardware. On top of hardware, what do you have? Firmware. Okay. On top of that, you have operating system. On top of that, you have applications. So even if you consider your mobile phone, there are all these things. There is a hardware, On top of hardware, we have a firmware, or we can call them as drivers. On top of that, we have got operating system. Then we have got applications. Okay. To understand what is hardware, what is firmware, what is operating system applications, let's take one example, simple analogy, then we'll come back to this discussion. Okay, let's take an example of a bus with passengers, right? So in this context, bus is like the hardware. In this context, bus is the hardware. Okay. Does bus move by automatically by itself? No. It needs a driver, the person who controls the bus. What could be the control? Moving, stopping, taking left turn, right turn, going back. Multiple controls are there, but there is a person who controls it. Bus automatically doesn't move. So that person is the driver. In our mobile phone or any electronic system, we are calling it as firmware or drivers. The term driver is, that's why even in mobile phone we use the term driver because of that only. Have you heard USB drivers anytime? We use the term USB drivers. What do you mean by the term USB drivers? These drivers control the USB hardware behavior. Since they control, what is meant by control? They will control when the data transfer should happen. Means these drivers will control when the data should move from my laptop to pen drive. When should we read from pen drive to laptop? That it's not like driver means they are going to move USB port from here and there or front and back. We are not literally taking like a bus example, but what we are telling, whatever hardware we have, the USB hardware, it will be controlled by whom? USB drivers. Now what exactly is a driver, we'll discuss in some time. Actually driver is not a hardware. Driver is a set of code that controls the USB behavior. Now coming back to the bus example, what is the role of a conductor in the bus? He one side connects with the driver. One side he talks to the driver, right? Other side whom he talks to? Passengers, right? The people who are traveling. So he communicates the information between passengers and the driver. Second, what else he does? He manages the seats for different people, seat allocation. Same thing operating system is also doing. Operating system is allocating the resources for applications. See, when you load your WhatsApp, if your phone is very low end, I mean where it doesn't have enough resource, will WhatsApp load? No, right? If it doesn't have enough RAM, it won't load, right? When your hardware resources are very less, let's say in a bus there are only 5 seats, for example. If 20 people want to sit, can conductor allocate? No. What he will try to do, he will see who is the best 5 people. I mean, let's say who are the old people. He will try to allocate for them. So same is the work done by the operating system. So two things it does majorly. On one side, it interfaces to the drivers, that is a firmware. On the other side, it interfaces with the applications. So whatever applications wants to talk to the driver or hardware, they all go through the operating system. Like let's say you want bus to stop. Do you go and map yourself will stop the bus? So what do? You tell to the conductor, conductor will tell to driver, driver will control the bus. So finally everything will be done by the driver only. You cannot do anything without driver related to the bus. Same is happening here also. The operating system applications will talk to operating system, operating system will talk to firmware, the firmware will finally control the hardware behavior. What else is done by the firmware, sorry, operating system? It allocates the resources. See, my mobile phone has limited resources. What is limited resources? Limited RAM. Let's say it is 12 GB RAM, assume. In the 12 GB RAM, I cannot run all my applications. My mobile phone has, let's say, 50 applications. If I load all 50 applications, my mobile phone will crash. Crash means its RAM size doesn't support all that. You might have noticed in your laptop also. Can you load all applications at once? Whatever is installed in your OS? No, right? Because my system, if it doesn't have sufficient resources, it won't support it. So that allocation is also done by the operating system. So you can easily understand an electronic system by taking this analogy: a bus with a passengers. So what are we trying to learn here? What are we trying to understand here? Our idea is not to become expert with drivers or expert with OS and all that. We are trying to understand what is the difference between hardware, firmware, operating system, and the applications. Okay. So let's now go through the presentation and try to get a brief about what is what. Then hopefully you will have a good idea about what is meant by VLSI, what is meant by embedded systems, what does a software engineer do. So let's start with understanding what goes into a mobile phone. So this is how mobile phone look like, and if you open it, this is how it look like. So what comes to your mind is just the hardware. But as I said before, just the hardware alone does not work. You need to have few more things that need to be put on top of this. What is that? What all things that make up the mobile phone? You have got the hardware. What is hardware? Different types of chips, different processors, screen, USB ports, camera, sensors, audio, different things, right? Other than that, there are things which we don't see, like firmware, which constitutes the drivers. Then you have got the operating system, like it could be Android operating system, iOS. Other than that, you have got different applications. So these all things collectively is what makes the electronic system. You see, if you take mobile phone example, as we discussed earlier, it has got how many layers? Totally 4 layers. At very bottom, you have got the hardware layer, which consists of different hardware like processors, cameras, sensors, different types of chips. Who develops the hardware? It is the VLSI engineer. As a VLSI engineer, our responsibility is to develop the hardware. What is the next layer? Firmware or drivers. Who develops firmware? Embedded system engineer. So here we are trying to understand that fine difference between VLSI and embedded system, because many times before even you came to this room for VLSI training, you would have thought, what is embedded systems? Should I go for embedded system training or should I go for VLSI training? So we are just trying to understand what is VLSI, what is embedded system. In the example, bus example, the people who manufacture the bus are the hardware engineers, are the VLS engineers. The people who develops the drivers, I mean, how to drive the bus, those people are embedded system engineers. Okay. There's a difference, right? See, do you think embedded system engineer, the driver, will he go and manufacture the bus? I'm driving a bus. Will I go and manufacture a bus? No, right? What is the knowledge I need to know? I need to know how the bus works, how to control the bus, where is brake, where is accelerator, where is clutch, where is handbrake. So there are multiple things, right? Same thing is what a embedded system engineer needs to know. Embedded system engineer also needs to know how the bus works, but he doesn't need to know how to manufacture the bus. Sorry, how to manufacture the chip. But he needs to know how the chip works, what all controls he has got. How can he control USB behavior? How can he control this thing, some processor behavior or USB behavior? How can he control PCI Express behavior? I will explain you what is meant by controlling. See, controlling doesn't mean moving the here and there. It's about making it do the things. For example, when you connect a pen drive and start doing transfer, someone is making the data move from laptop to pen drive, right? Someone. Who is that someone? That someone is drivers. Whenever you connect a pen drive, you go to the this one and you say right click, move data. Where are you starting this control at? Application level. Application level are probably at the operating system level. You are starting it at what level? Operating system level. From the operating system level, the control goes to, it will inform the firmware, that is the drivers, that you are supposed to do this work. What work? There is this file which is present in this directory. This need to be moved into the pen drive. Then the drivers will inform the processor to start doing that work. It's like you wanted the bus to stop. Here it's like here you wanted to move the data. In bus example, what you wanted to do? You wanted to stop the bus. Did you go and apply the brake? No. What did you do? You informed conductor. Same way here also. When you wanted, you are informing operating system what you want to do. Then what conductor did in bus example? He told the driver that you have to stop. Same thing, my operating system tells to the driver that there is a requirement for moving the data. So you are supposed to do this work. So then operating, my drivers will do some specific instruction execution. Understand? The drivers will consist of specific instructions, which will result in data being moved from my laptop to the pen drive. So let's do little deep dive into it. I mean, finally, our goal is to understand when people keep selling USB driver, people keep telling NVMe drivers, okay, SATA drivers, different drivers. What exactly is a driver? Let's try to understand. We don't need to develop drivers because we are not doing embedded system course, but we still need to know what is a driver and how does it work. Once it is done, then we'll keep our 100% focus back into VLSI because our main focus is to learn VLSI. Okay. So who develops the firmware or drivers? Embedded system engineer. Third is what? Operating system. Android OS, iOS, Windows, Linux, everything. Who develops it? It's a software engineer. What is the fourth layer? Applications, right? See, even for mobile phone, applications are very important. Without applications, it is not of much use. Why do you people go for iOS or anything? Because it provides that ecosystem with lot of apps. Same thing here, different apps in mobile like GPay, different things, right? Who develops them? Either software engineer or the app developers. For an electronic system to work properly, all these layers are important. Okay, can you imagine a mobile phone without a hardware? No. Can we imagine without operating system? Let's say someone gives you hardware but with no operating system. Again, no applications. So everything is important, right? So the point is what? It's not like I'm a VLS engineer, my work is very important. It's like someone is telling embedded system is very important. Not like that. Everything has its own importance in the flow. All these things are essential for for electronic system to work efficiently. I have already given you a bus analogy. Okay. We time to time will take such analogies to make it easy for you to understand. Next. What exactly is a driver? Let's try to understand. Whenever we say USB driver, means I connect a pen drive, it says that USB drivers are not installed. So without that, it won't let me do the transfer. Okay. So what is USB driver?
Something which helps the communication between the computer and
Pen drive. Yes.
It needs to talk to each other. That's why.
Yes, exactly. So my laptop will have different types of drivers. I'll give you again same analogy, bus analogy. You've got bus, train, aeroplane, different vehicles are there. Okay. Do you think same driver can drive all vehicles? No, right? See, say, I can drive a car, but do you think I can drive a truck? No, right? Because it may require little different expertise. Someone who drives truck may not drive tractor because it's a different expertise. So like if there are 10 different hardwares, 10 different vehicles, you may need 10 different drivers also. Even in my laptop, if there are different controllers, let's say USB controller, PCI Express controller, DDR controller. So I'm not trying to confuse you. I'm just trying to give you a top level picture. Okay, to control each of these hardware, to control the USB related hardware, what we particularly called as USB controller, you need USB drivers. To control DDR related transfers, DDR controller, you need DDR drivers. Like that, for every hardware in my laptop, every smart part in my laptop, it will require one driver. Now let us understand what exactly is the driver is about. Essentially, driver is a set of assembly language instructions. If you go deep, when people say USB drivers, it says some millions of lines of assembly instructions. When I say set of assembly instruction, that means millions of lines. What is an example of assembly instruction? Can someone tell me? Any simple assembly instruction, any processor, add R1, 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 R2. Is this an assembly instruction? What are we doing? We are adding R1 and R2. We are putting the result into R1. So like that, right? There are different types of assembly instructions: add instruction, multiply instruction, subtract instruction, compare instructions. For example, compare will be there, R1, R2. What are we doing? We are comparing R1 and R2. So like that, there are different types of instructions are there in the, now it could be ARM processor, it could be x86 processor, anything. But there are different types of instructions that constitutes the assembly language. When we say USB drivers, not exactly this line. Okay, don't think that always this line will be there. Something like that, millions of lines will be there. Finally, what are those lines? What is that code? Okay, that code is nothing but, see, even if it is little difficult for you to understand, try to focus. I mean, try to understand. I do agree that you may not have any exposure to, some of you may not have any exposure to assembly language because your curriculum may not have covered those things, but still I'm trying to give a top level overview. Okay, so that you have an idea what is embedded system, what is VLSI, how our work is different from embedded system engineer work. Okay, but I'll try to make it as simple as possible for you to understand. I will try to make this whole discussion as simple as possible for you to understand. Okay, so we were discussing about some of the driver examples. In that, we have particularly taken USB driver. So at the top level, what is an USB driver? It is the one which controls the USB hardware behavior. What is meant by controlling? It, the USB driver will decide when to move data from laptop to pen drive, or USB driver will decide when to move data from pen drive to laptop. USB driver will decide when to put pen drive into a sleep mode so that power is less, power is, power consumption is less. So these kind of decisions it makes. It's like bus driver is there, you agree his role is to drive the bus, stop the bus. Let's say he goes to a traffic signal, He knows that bus is going to be, traffic signal will be there for red, will be there for 3 minutes. What do you think he should do? He will turn off the bus, and then after 3 minutes he will turn on. So who is making the decision? The driver is making the decision, right? Why he is turning off for 3 minutes? To save the fuel. Same thing here also. The USB driver will make a decision. Okay, you see, I'm not going to use the pen drive for next 5 minutes. Right now there is no need of any data transfers. Let me put all the USB hardware into low power state. Exactly same thing it does. Only difference in case of, how does the USB driver control how USB driver controls the USB hardware, or the USB controller or hardware. In case of bus example, how bus driver controls? Accelerator, brake, clutch, gears. I mean, okay, I'm not trying to teach the car and bus here. Like the way this person controls through accelerator, brake, clutch, and gears and these things. In USB, there is something called as, every USB controller has lot of registers. What is that? It has got lot of registers. Registers are nothing but set of flip-flops. These are the storage elements. Have you heard of flip-flop? Flip-flop is a storage element, right? One flip-flop can store how many bits? 1 bit. Generally, register will be 32 bits. To store 32 bits, how many flip-flops do you need? 32 flip-flops. So you can say 32 flip-flops. 32 flip-flops makes one register. The USB controller will have multiple such registers. USB controller will have multiple such register. Let me just draw in the diagram. If this is my mobile hardware chip, in that somewhere here there will be USB controller. Inside the USB controller, even in my mobile phone, there is a USB controller is there. Inside that, there will be some registers will be there. Registers. Each register is how much size? 32 bit size. Means each register is manufactured using 32 flip-flops. When they manufacture in the silicon, right, they'll be manufacturing 32 flip-flops to make one register. My processor sitting here, which is the processor I'm talking about. When you buy mobile phone, you have different processors, right? Qualcomm Snapdragon processor, Tegra processor, depending upon which one you take, MediaTek processor, right? Different processors will be there. What they will do is, this processor, based on the instructions from the USB driver, it goes and does some updates to these registers. What does that do? The processor, what is the blue box I have drawn? Processor. It runs some instructions. It's like I'm the processor. Okay, someone is the USB controller, other person is the USB controller. I independently don't control him. Someone is giving me instructions. In what format those instructions are? Assembly language instruction. Because as a processor, which language do I understand? I don't understand English. If I'm a processor, ARM processor or anything, I don't understand English. I don't even understand Verilog language. Only language I understand is I have some machine language, my own particular language. Okay, that is what we essentially call as assembly language instructions. Let's repeat again. Assembly language instructions. I am the processor, he is the USB controller. I want to control his behavior. What is that I want him to do? I want him to start sending some data to pen drive. Okay, but I don't want to do that work. I don't want to go and do the transfer. I want to control him. I want to go and tell him that you start doing the transfer. See, there is a pen drive connected here. You start doing the transfers to the pen drive. So what will I do? He has some registers. Okay, I each register has a particular meaning. Okay, each register has some particular meaning. Okay. By programming those registers, you understand the term programming means by setting some values into those registers. I will tell him that this is the work you are supposed to do. Either you are supposed to write the data or you are supposed to read the data. Since I have told him the instructions, what do you think he will start doing? Since he's master, like I'm like the master to him, I have told him he will start doing the work. What is that he will start doing? He will start either sending the data, he will start receiving the data. That is how I, as a processor, able to control his behavior. But who is controlling me? I am not working independently. Someone is telling me to work. Someone is telling me to do particular work. Who is that person? That is the drivers. As a processor, who am I? I am the processor. I don't work independently. Someone has to give me instructions. Who is that someone? Drivers. So the drivers will give the instructions. What is the drivers will consist of? Millions of instructions. Add instructions, subtract instruction, compare instructions, branch instruction. You know, right? If you have gone through any x86 or ARM RISC instruction set, you would have come across around 30-40 types of instruction examples. If you ask me, do I need to know all those things for this course? No need. We are just trying to get a top level overview of what is what. Because directly starting with Verilog, directly starting with system Verilog, it's good to get a bigger picture, then go one to the next level down. Okay, let's come back to this discussion. So we are talking about, initially we started off all our discussion with what? Understanding electronic systems. We understood that electronic system consists of 4 layers. At the down you have got hardware. On top of hardware, drivers or firmware, or you can call embedded systems. Then on top of firmware, what you have? Operating system. On top of operating system, you have got applications. So we are trying to understand how each layer controls the one layer below it. So now here we are trying to understand how the drivers will control the hardware.
Who does the driver?
I am telling, at the operating system level, I'm the person who made this decision, right? I went here, if you see, I did right click, then I said move the file. That's how it happens, right? When I said move the file, do you think am I working at hardware level, driver level, or operating system level? Operating system. Whatever I'm doing here is operating system only, right? From the operating system, it will inform to the USB drivers. There is a work specific to USB driver. It's like in my house, there are 10 different vehicles are there. 10 different vehicles are there. Okay. I want to move some lot of luggage to some other city. One of the vehicle I have is a truck. One of the vehicle I have a car. One of the vehicle I have is a cycle. Other is bicycle. I want to move lot of luggage to other city. Which vehicle will I select? Truck. Same way, operating system also decides. User wants to move the file to pen drive. So which driver should I call? Should I call USB driver? Should I call DDR driver? Should I call PCI driver? USB driver, because my work is related to whom? USB, right? The user at the operating system level is asking for what work? Moving the data to the pen drive. So anything related to pen drive falls into whose work? USB. So coming back to my house example, whom will I select? I will select the truck driver. I will not select the bike driver. I will select the truck driver. I will tell him that you are supposed to do this work. What will I tell him? I am the driver now. So I'll tell him that this is the luggage. You have to load. You have to go to this city and you have to drop it there. Same thing exactly is happening in the USB drivers also. Like, but I tell to him in my native language or whatever, right? But here the language is assembly level instructions. This USB drivers consists of some assembly language code, add instructions, subtract instructions, some millions. Now, how did we arrive at add, subtract, and compare? Let's not discuss now, but understand that eventually it is all those instructions. So the processor keeps getting these instructions one by one, will start executing. Let's say if it is an add instruction, processor will do addition. If it is a load instruction, it will load the value. If it is a move instruction, it will move the value. If it is a store instruction, it will store the value. It will do those instructions. As part of that work, the processor will go and program the registers. Who is programming whom? Processor is programming the registers sitting inside USB controller. Let's again repeat. Where are the registers present? In the USB controller. Registers are present in USB controller. Who is programming them? Processor. Processor is programming them. By programming particular values, the best example to understand this programming is a washing machine. When you are using washing machine, does it always work in same mode? No, right? As you change the knobs, it works in different modes. Sometimes in 1 hour wash mode, sometimes in 15 minutes quick wash mode, sometimes it runs for 2 hours also. You are changing the knob. You know what you are doing actually changing the knobs? Tell me. By changing the knobs, you are changing the register programming. You are programming different values into the washing machine registers. Washing machine also internally has registers actually also. By changing the knobs, you're programming different values each time. So based on that, it knows that, okay, now I have to work in 15 minutes quick wash mode. Now I have to work for 45 minutes wash mode. Same thing happening here. It's like the communication between me and him. Who am I in our example? I am the processor. Who is he? USB controller. All our communication happens by me programming his registers. Anything I want him to do, whatever be the case. Let's say I want him to sleep in the classroom. Let's say I want him to start doing the data transfers. Let's say I want him to read the data from some place. All I will tell to him by programming his registers. He will have registers. By programming his registers, I will tell how he should behave. If his work is more complex, do you think will he have less registers or more registers? More registers, because more things he has to do, more registers will have. If his work is very simple, less registers. That is how we measure the design complexity. Let's say if I have to tell whether USB controller is complex or simple. Okay. Let's say if I have to tell whether USB controller is complex or simpler. One measure is only there. Number of registers. More the number of registers, more complex is the design. Less the number of registers. Less means what? One register, two registers. Then it's very simple design. Okay. Again, I want to repeat. There is a possibility that many of you are finding it complex. But that's okay. I mean, every day it won't be same level of complexity. Tomorrow when we start off with the very basics of what is AND gate, what is OR gate, what is truth table, what is K-map. So we will not start with processors and the controllers every day. As a demo session, we are trying to get a bigger level picture. I don't want to tell our course is 8 hours a day, 6 months. Rather than that, it's a good idea to just get a top level picture of what is what and how our course will be relevant. That's what I'm trying to structure the course. Finally, we'll definitely go over all your questions. So my point I'm trying to communicate is don't think that every day will be similar level of complexity. The course always starts with the fundamentals. Then it just goes up. But here, since in 1-2 hours, I'm trying to give a bigger picture. So there I'm talking about few terms which are new to you. Okay. So let's write down all this as a short notes. When user wants to do some transfer to pen drive, okay, the transfer is initiated in OS, in the that folder, right? In the, I'll go to the specific folder and I will initiate the transfer. Then operating system figures out that transfer is to where? Is to pen drive. That means which driver should I call? Which driver should I call? USB driver, because the operating system has lot of drivers. Operating system has a USB driver. Operating system has a DDR driver. It's like in my house, I said, right? We have, let's say I've got bus driver, car driver, truck driver, different drivers I have access. But which driver will I select? Depends upon what work I want to do. In this example, I wanted to do some transfer to pen drive. So I selected whom? USB driver, because pen drive is the work of a USB. So the operating system will ask USB driver to initiate the transfer to pen drive. The USB driver, okay, please read it once. First, let's again read. User wants to do some transfers to pen drive. Transfer is initiated by going to the Microsoft folders, right? I went to the folder and I right click and transfer. Right click, then move the file or whatever. Then operating system figures that transfer is to the pen drive. So since it is to the pen drive, which driver should I call? Yes, USB driver. So who is doing that? Operating system is making the decision. Operating system is making a decision that this work is related to USB. So let me call USB driver for this work. So operating system will ask USB driver to initiate the transfer to the pen drive. So the what USB driver will do? USB driver consists of, this is important statement, consists of lot of assembly language instructions. This work of developing these instructions is the work of the embedded system engineer. If you ask me, someone is becoming embedded system engineer, what is his work? His work is to develop these instructions, these drivers. He is responsible for developing USB drivers, developing DDR drivers. Okay. What is that USB driver will do? What is the final work? What is the final work of USB driver? It is to program registers present in the USB controller. What is the work of USB driver? It is to program the registers present in the USB controller. These, by programming these registers, USB controller starts working. It's like it either starts sending the data to the pen drive or it starts reading the data from the pen drive. But finally, from where my processor is getting the instructions? Okay. One thing I missed here. These instructions will be read by the processor. See, processor is very important. See, processor is the one who gets the instructions from the drivers, and it understands, okay, user wants to write to this register, user wants to read from this register. So processor programs these registers, processor programs the registers present in the USB controller. By programming these registers, USB controller starts working. Means what? Starts doing transfers. It starts doing the transfers. That is how it is all happening. I'll just show you one simple diagram. See, when USB is connected to the laptop, USB device gets detected. Okay, we start doing the transfer. I think I have explained you how it works. Okay, embedded system engineer develops the USB drivers. He won't develop the assembly language code. The person, let's say someone is embedded system engineer. Assume I am the embedded system engineer. I will not develop all my code using assembly language. Which language will I do? Embedded C. Embedded C language I'll use. Then there will be something called as compilers will be there. Compiler, which will take this embedded C code as an input. This is what? Compiler. Okay. It takes the embedded C code as an input and it gives the actual assembly code, assembly instructions. When I say assembly code, it will give assembly language instructions. So this, it is more easy to develop in embedded C than assembly language instruction. Simple example, if I ask you to write a for loop to add some array contents, I want you to add some array of numbers. Which is more easy, writing in C language or writing in assembly language? C, right? Let me repeat my question. I want you to add array of integers. One is use C language, one use assembly language. Which one do you find it more easy to do? C language, because it's simple. You have to write a for loop, then you have to just add the integers array. In assembly language, lot of things you have to do. You have to keep branching, you have to keep checking. So almost what it takes here, 3 lines, here it becomes almost 10 to 15 lines. Same work it will require 10 to 15 lines, because you have to, then you have to remember each instruction. The flags will be there, some, right, comparison. When you do, some flags will be there, 0 flag, minus flag, all those things you have to worry. So even embedded system engineer has the same problem. What embedded system engineer does is, he won't directly develop in assembly language. You develop in C language or embedded C, then he converts this into assembly language by using compiler. Why it has to be converted? Can you tell me? What happens if I don't convert it? My processor don't understand C language. If I am a processor, I don't understand C language. I only understand my language. What is my language? Assembly language. So in between, he uses one compiler which will understand the C language and convert it to assembly language. Then he can give me assembly language, because I will understand instructions in assembly language. So this is all how it works. In summary, embedded system engineer is responsible for development of drivers. Okay, he is not responsible for development of hardware. Let's say someone into embedded systems, they don't need to know how to develop the hardware. They only need to know how to develop the applications which control the hardware. Okay, if you look at this diagram, it has got different components: USB, PCI Express, Ethernet, Wi-Fi, LPDDR, HDMI, MIPI. Okay. To control each of them, I'll have one driver. There will be a driver for DDR. There will be a USB driver. There will be a PCI Express driver. There will be Ethernet drivers, Wi-Fi driver, webcam driver. For everything, there will be a driver. At top level, as a user, when I start some work, if I want to turn on webcam, so my operating system understands what? User wants to turn on a webcam. So what it will do? Which driver will it call? Webcam driver. Do you think will it call PCI driver? No, right? It has nothing to do with webcam because PCI driver cannot control webcam. It's like someone who drives a bike cannot control a bus because he doesn't know how to use the bus. Same way, my operating system has all the drivers. What is the first driver? USB driver. Who is the second one? DDR driver. Third one is PCI driver. Drivers is not like some hardware or anything. It's a piece of code. In my memory, this portion of the memory is USB driver. This portion of the memory is PCI driver. So the processor will call that part of the code and it will start executing that piece of code. Executing means what? Running those instructions. You know, right? Processor fetches the instruction, gets the instructions, and decodes the instructions and executes. You might have studied fetch, decode, execute. Fetching means what? Getting the instruction. Execute means what? Sorry, decode means what? Understand the instruction. Execute means what? Do that instruction. Work as per the instruction. When you run one particular driver, processor will run all those things. In this example, these are the different processors. They will start getting the instructions and they will start accordingly doing the programming to the control. This shows the same example. Here I have USB controller. Here I have pen drive connected. Here I have the processor. Here I have the DDR memory where different drivers are present. What is the significance of DDR? In my laptop also, DDR is the place where all my drivers will be present. Going back to the, yes, going back to my bus example, my house example or somewhere, I have access to different drivers, right? Where are they sitting? They're sitting in some place. In my laptop, that place is DDR. Somewhere that code need to be present, right? In my mobile phone or laptop, somewhere those drivers should be present. What is that place where they are present? That is DDR memory. DDR is the place where all those drivers are present. Which driver? This is USB driver. This is DDR driver. This is PCI driver. This is SATA driver. Different drivers are there. Okay. So when operating system initiates some work, so the operating system will activate one of the drivers. Will tell you are the person who is supposed to do the work now. Okay. Then those instructions will be taken by the processor and it will program here. Then the transfers will happen. Let me repeat it for one last time. This is the entire laptop. At the very top level in laptop, what do you have? Operating system. Somewhere in operating system, you went and you said some work. You right click and you did some work. Then it went to the operating system. It figured that what is the nature of work? Okay, user wants to start the webcam. It's like my webcam is on now. Okay, user wants to start the webcam. So it has got different drivers with them. Where are those drivers relaxing and sitting? They are sitting in the DDR. So the operating system figures that, okay, I need access to which driver? Webcam driver. Now, if I want to turn on webcam driver, will I go and ask USB driver? No, right? Because USB is not related to webcam. So among the available drivers, I will select, okay, webcam driver is the one whom I have to talk to. So it will tell that driver to start controlling the processor. Then processor has something called as, it goes and reads those data instructions, that is called as fetch. F means what? Fetch. Okay. These instructions actually will come in a binary format. They will come in binary format. Means what? They'll come in bits format. I'll give you an example. Something like this. It won't be like add, it won't be like subtract like that. When I get this piece of code, this number, the processor has to understand what is meant by this number. It's like I'm giving you one code, I'm asking you to figure out what is that. You will finally figure out that, okay, this means add R1, R1, R2. This means compare R1, R2. You will,
This is the processor giving the code.
no. This code is present inside the my drivers. When I said drivers, even if you take your USB drivers, though initially I said it's a add instruction, subtract instructions, but it won't be in English. See, add is a English word, right? Subtract is a English word. So they won't be English words. Everything will be ones and zeros. Those ones and zeros are these things. This line means this. That process is called as decode. Fetching means getting that hexadecimal number. Fetching means what? Where is that hexadecimal number present? It is part of the driver. Where is the driver present? It is present in DDR. Okay, it is present in DDR. Initially, actually, it's not there even in DDR. When you started your laptop, your DDR is completely empty. It is all present in your storage, SSD. From SSD, it has moved to DDR. Then when you
Sort of partition that we do in the C drive that we
yes, something similar to that. Yes, exactly. So in that case, what happened? When you start running some driver, processor gets these numbers from the memory. The processor understands, okay, first number means what? I have to do the add operation. Second number means what? I have to do comparison operation. Then third number means I have to do some again subtraction operation. Like that, different instructions, it just keeps executing. Okay. As per that, so first what it did do? Fetch. Fetching means what? Processor reading the data. It's like me going somewhere and getting these numbers. That is called as fetching. I'm getting it. Once I get those numbers, what will I do? I'll decode. What does that number mean? Does it mean add instruction? Does it mean subtract instruction? Then finally, what will I do as per that? Execute. Fetch, decode, execute. Every processor works in this manner. It's a very simple guideline. Processor is fetching the instructions, decoding the instructions, executing the instructions.
Where are these numbers kept? This H2, H1. Where does it go to? Where does it store these numbers?
These numbers are present in my DDR. If this is my DDR, okay, when you, let's say my laptop is off. When I turn on my laptop, my storage is there, right? What is storage in your laptop? Tell me. HDD, one of them, right? From there, some here all drivers will be present. They will be moved into DDR. Why? Because my processor only works with DDR. Processor doesn't talk to SSDs directly. My processor will always work with DDR. Okay. So then at the operating system level, I have given some work. What is the work just now we discussed? Turning on a webcam. So which driver will I select? Webcam driver. Let's say this is the driver I selected. This is this code. That hexadecimal numbers you see, 32 tick H, all those. It is actually what is present here. It's just that how many
installed.
they are already present.
Yeah.
Okay.
By an embedded engineer. Right?
Yes. Embedded system engineer is the person who used initially C language to develop the things. He compiles, he initially gets this kind of thing that further gets converted into hexadecimal code. And he releases it as a opcode. He releases it like a opcode, hexadecimal code. That when I get it, when I install in my laptop, that is one of my drivers my laptop has. Okay, they become integrated with the operating system. The operating system knows if this is the work, I have to select this driver. It's like going back to our transport example. If I want to just drop one person at railway station somewhere, what will I select? I'll select a bike driver. Someone I want to drop at airport, I'll select car driver. So according to the work I have, I'll select the drivers. Finally, what is a driver? This kind of millions of instructions. Even though how many numbers did I show here? Only 3 numbers, but actually it will be millions of lines will be there. Okay, because you can imagine a what is an example? When you install USB drivers, they won't be kilobytes, there will be multiple megabytes, 200 megabytes like that. 200 megabytes means some hundreds of millions of instructions actually, because one line is how many bytes? 4 bytes. So 200 megabytes means you do the conversion, it will come to some instructions. Anyway, we don't want to get so much deep into it. Finally, what is our goal? Let's write down the understanding. At the end of this lecture, you should know what is meant by drivers. When we say USB drivers, now can you correlate what is USB driver? Right? Drivers are assembly language instructions provided in the format of hexadecimal codes. In what format these drivers will be provided? Hexadecimal codes. Hexadecimal means what? These numbers 3902930, like that. I mean, you may say same thing is there. No, it's different. Okay, each thing has some meaning. Okay. Who develops this assembly drivers? Embedded system engineer uses embedded C language to develop the drivers. But internally, what he will do? Embedded C language, C code, he will convert it into assembly language code, which is finally converted into hexadecimal codes. These codes are called as opcodes. In the processor terminology, these terms are called as opcode. So this is like one opcode. The first number you see, this number is called as one opcode. This second number is called as second opcode, third opcode, multiple opcodes. OP code, operation code. Operation code. What operation do you want to do? Do you want to do addition operation? Do you want to do subtraction operation? Do you want to do multiplication operation? Do you want to do store operation? That code. So okay, next. How the operating system to hardware control works. Operating system, based on the current work, selects the right driver. It's like it'll either select webcam driver, it'll select either USB driver, it'll either select DDR driver or PCI driver, one of them. Okay. Then informs the processor to start following that driver instructions. It's like I'm telling to the bus, you have to follow the bus driver behavior. Whatever bus driver does, you work accordingly. Okay. Then what processor will do? Processor present inside my laptop, my hardware. Every hardware will have a processor. What it will do? It fetches the instructions. It fetches these above opcodes, that is hexadecimal numbers. Decodes the opcode to get assembly level instruction. It will figure out what to do. See that number, tell me, if I give you this number, you may ask, what is this number? That answer is the decoding. It's like, okay, this number means addition of these two. This number means comparison. This number means something else. That is called as decoding. Then executes the instruction. Executes the instruction. Fetch the opcode, decode the opcode, and execute the instruction. Eventually, you know what they will all do? What is that it will all involve? It will all result in, finally the final work will be, final summary will be, processor programs some registers inside the USB controller or webcam controller. Somewhere, let's say when I want to control webcam, there will be one webcam controller will be there, actually camera controller will be there. I will go and program that controller to turn on the webcam. In case of webcam, in case of pen drive, I'll go and program the USB controller to start doing the transfers. So this is what is involved. See, finally all this work is translating into line number 61. Understood? Even if you didn't understood everything, that's okay. Okay, because we don't want you to become expert in 2 hours. Right? Can you become embedded system expert in 2 hours? All right. We are trying to get a top level picture of what is what. Okay. But at least now, if you can, you know what is operating system, what is the driver, what is the hardware. Now, can you tell me difference between VLSI engineer and embedded system engineer? Right. VLSI engineer develops the hardware. Embedded system engineer develops the drivers which control the hardware. There's a big difference, right? Right. Use case. One more use case let's take. Let's say currently my mobile phone, if I don't use for some time, after 30 seconds, it will turn off. You know, right? The screen will go blank after 30 seconds. Let's say I want to change it to 60 seconds. How do you change it? Do you open the hardware and stick some number 60 inside the hardware? No, right? What do? You go to some settings. How do we do? Open the settings. That is at application level. Change 30 to 60. This instruction, see, understand, whatever you are changing, it will go to OS. So, okay, OS understands that user wants to change the display turn off time. It is still at operating system level only. Operating system conveys this to which driver now? Power management driver. See, it is not calling USB driver because it is not the work of USB and it is not even the work of webcam. Which driver I am calling now? Power management driver. I told you, right? My laptop has many drivers. One of the drivers I have is power management driver. This driver consists of instructions for processor writing to a register. See, I told you, right? Finally, it involve processor writing into a register in the design to change the number 30 to 60. Finally, somewhere the number will be reprogrammed, based on which my display behavior will change. Okay. Now, as a VLSI engineer, what is the understanding you require? As a VLSI engineer, you need to understand how hardware works, should have an in-depth understanding of hardware development process, because you are developing the hardware. You should know each and every process in the hardware development. You should have an understanding of how firmware interfaces with hardware. I mean, how does the communication between hardware and drivers happens? That basic information you should have. Basic understanding of how firmware works with hardware. You don't need to have any understanding of operating system and applications. I don't need to have a understanding of how operating system will work, how applications will work. My only work will be as a hardware, how I have to develop, and I am interfacing with embedded system. So how does the drivers will connect with me? Okay, because when I'm manufacturing a bus, I should make sure that my bus should be convenient for driver to use. So those two knowledge I should have. Okay, that's the reason we have gone through this part of that.
Every hardware needs to have a driver. Every hardware requires a driver.
Drivers, yes. Okay. So let's go for a break. I think it's already 1 hour 20 minutes. So we'll meet in 10 minutes. So that's around 11.
This conference will now be recorded.
So let's start with the quick revision of what we have discussed before break. So before break, we were discussing about what is an electronic system. We took an example of a mobile phone. We understood that any electronic system, it can be my mobile phone, it can be laptop, anything consists of 4 layers. At the very basic, you have hardware layer, then you have got firmware, then you have got operating system. On top of operating system, we have applications. Applications is everything, even the MS Office we use, everything is an example of a application.
User interfaces with the system only through application.
Applications, yes, right. But sometimes you interface through operating system also, right? Like you're directly going into folder and doing, that's like operating system only, right? Sometimes through operating system, sometimes through application.
Is
Okay.
folder also sort of application?
No, it depends upon what is your definition. Okay, fine, let's take it application only. Okay, fine. Then we understood the person who develops the hardware is called as VLS engineer. The person who develops firmware is called as embedded system engineer, right? And we understood what is meant by a driver, what exactly it consists of. Okay, so that was all about VLSI and embedded system and electronic system. Okay, now let's talk about so now let's talk about VLSI design styles. So now that we have understood what is VLSI, what is embedded system, now let's do little deep dive into VLSI. So as you know, VLSI is about manufacturing of the hardware, right? Okay. As a VLSI engineer, I don't worry about how to develop drivers, how to develop operating system. I don't think about. My only role is how can I develop the hardware. Develop hardware, there are different roles are there. I can be a PCB engineer, printed circuit board engineer. Even as a PCB engineer, I will do hardware development. As a VLSI engineer also, I am developing hardware. So depending upon what is that finally you are doing, either you are a VLSI engineer, either you are a PCB engineer, either you are a FPGA engineer, different things. So let's now talk specifically related to VLSI. See, VLSI term stands for what? Very large scale integration. let's understand what is meant by integration. Say, small example, this building is there. What did we integrate for this building? Lakhs of bricks or thousands of bricks. We integrated many bricks to get a structure, to get the one structure. In VLSI, what are we integrating? Transistors. We are integrating transistors. You might have heard MOSFET, FinFET, right? So this is an example of a MOSFET. What type of MOSFET is it? NMOS or PMOS? It is a NMOS. How to make it PMOS? If you circle, it's a PMOS, right? Like that, billions of such transistors. So this is one transistors. This is gate, this is source, this is drain, this is substrate. Billions of such transistors are integrated to get one chip. Okay. Now, how it happens, that's different part. I mean, that is a part of the VLSI design process. But understand that my mobile phone will have finally billions of such transistors. Okay. Since we are integrating billions of transistors, it is called as very large scale. Okay. This VLSI, whatever we want to do, let's take this building example. This building could be constructed in two ways. One is what? You start everything from scratch. What is scratch? The ground, you put the foundation, then you start building floor by floor, this one. Then you start putting each brick. That is one style. What is the other style of construction? Possibly someone already gives you prefabricated rooms. Someone gives you one room prefabricated, another room prefabricated. You bring all the rooms, just put together and make one house. That is also possible, right? There are some places where you see that is also happening, right? They already, someone is giving you the structures. Both are possible. Like in house construction, we are able to construct the house in multiple ways. Either through from scratch you are developing, where you don't have anything, you're brick by brick you are arranging and constructing. Other is what? Someone has already developed the individual units. You're just putting together the units to come up with a bigger structure. In VLSI also like that, two major approaches are there. One is called as ASIC, other is called as FPGA. ASIC is similar to, ASIC stands for application specific integrated circuit. In this case, it is similar to constructing the house brick by brick. Okay. We do from scratch. Hardware developed for specific applications. Means, if you go to Qualcomm, let's say, they are developing those chips, right? Snapdragon chips. You might have heard in the mobile phone Snapdragon, they will tell 851, something will be coming, right? That chip, what they develop? Laptop? In some printer, same chip? No. They are developing it for specific application. That's why it is application specific. They are developing a circuit, integrated circuit. Chip is the integrated circuit. They are developing it for particular application. That's why it is called as ASIC, application specific integrated circuit. It's like if I build this house, this is particularly working as a my purpose. Whereas if I go and buy the individual structures like 3D printed or whatever, right? Those structures, they can be customized for different requirements. I can buy one of them and I can use it for some other purpose. Okay. What is that? Is the FPGA. Not exactly the same work. Like my correlation is simple. When you wanted to construct the house, you had two approaches. One, you do everything from scratch. Second thing is you put together the pre-existing structures. You take the pre-existing structures and with that only you build it. Which one will get over quickly? Which work will get over quickly? Building from scratch by taking the pre-existing structures. putting together the pre-existing structures. Same way, FPGA also gets over quickly. I mean, can get over quickly by using the pre-existing board. We call this as FPGA board. I mean, this is not the one, but there will be FPGA board. In that, all the hardware elements will be there, and you program it for your requirements. You program that for your own requirements. Okay. Whereas in ASIC, you don't have anything. It's like a plain paper. On that, you are doing everything from base. Okay. Talking of, yes, but then if you have to construct a house, you still had, if you go to across the Bangalore, there are 100 house constructions. You will see which one people are still using. Are they using pre-existing structures? Are they constructing from scratch? Why do you think? I mean, which one it looked easy? I mean, on paper, which one looked better? Pre-existing structure, right? If you look on paper, which one looked better? Pre-existing structure looked better. Then why people are going again from scratch? Everyone has their own requirement because limitations. They want to do optimize the space in their own requirement, right? Suppose some puja I want to keep somewhere. The pre-existing structure may not give me that kind of flexibility. Cost, it could be generally costlier because they're giving some pre-structures. They have to move. A lot of things will be there. Whereas when I build everything from scratch, I have my own choice. Same is the difference between ASIC and FPGA. In FPGA stands for field programmable gate array. Means you already have the array, gate array. Gate array means what? Array of gates. Tell me what is the gate I'm talking about? AND gate, OR gate, XOR gate, XNOR gate. Different gates, logic gates. Since it's a multiple gates, we are calling it as gate array. We can program their behavior. Can tell this should behave like an AND gate, this should behave like OR gate. So finally, I'll get the required hardware. Same FPGA board can be programmed to behave like different applications. It can be programmed to behave like a mobile phone. It can be programmed to behave like a laptop chip. Different things I can make it work. Which one looks better? It looks FPGA is better. Though it looks like FPGA is better, going by this, because here same board I can use as mobile phone, same board I can use as a laptop chip. Whereas in ASIC, what happens? It's only mobile phone. If I manufactured to work like a mobile phone, it's only mobile phone, nothing else. But still industry uses ASIC. Same as our house example. Even though you have many examples where people will give you prefabricated structure, everywhere, many places you will see people going for this one, scratch only. But there are places where people do use prefabricated structure, but it's less. Same is the relation here. Okay. Though it looks FPGA approach is better, however, industry prefers ASIC design flow due to low cost of manufacturing. What is the major important factor here? Cost. Cost is the important factor. How much could be the difference? Difference could be as much as if I develop this mobile phone using ASIC, let's say, if it cost me 15,000 rupees, let's say, just an example. Same mobile phone, if I manufacture with FPGA, it may cost me 40,000 rupees. Just for comparison, I mean FPGA manufacturing is always costlier than ASIC. Because in ASIC, what they do is they don't develop board by board. It's like how do you make Mysore pak? Sweet, right? They have a plate. In that they put all the cream, whatever, right? Then they cut the pak, that Mysore paks, right? They slice it. So each one is like one chip for us. Each one is like a one chip that goes into one mobile phone. This another mobile phone chip. This another mobile phone chip. So they put copies of all the chips in one wafer. That entire wafer they'll manufacture at once. That is ASIC. This is ASIC. FPGA is done in different manner. FPGA has its own integration costs and other things, which makes it more costlier.
This is
ASIC. This is ASIC. ASIC is like they manufacture one circular wafer. We have like plate, we have, right? Steel plate, that kind of silicon wafer. On that they'll put as many not transistors, chips as possible. So if they can manufacture 1,000 chips in one wafer, so the cost is one manufacturing unit divided by 1,000. So their ASIC cost will be cheaper. If ASIC is cheaper option, why don't we do everything in ASIC? If ASIC is cheaper, then why FPGA at all there? See, you might ask one question. Then why FPGA at all there?
Timeless.
For ASIC, initial investment is very high. If I do ASIC flow, my initial investment will be very high. I have to set up one flow that takes lot of cost. Let's take cost of ASIC design flow. Multiple $1 million. If I have to manufacture this chip, even to bring out one chip, only one. I don't want to manufacture million. I only want to manufacture one chip only, one mobile phone only using ASIC. I from scratch. So it will cost me multiple $1 million. But once the flow is working, once I know how one chip gets manufactured, it costs less because this one manufacture like that only. It's like you put entire cream onto that plate and you cut the slices right to get Mysore pak. Same thing you're doing here. On each part of the chip, each part of that wafer, you're putting your logic, and you are all bulk you're manufacturing. So that way, cheaper compared to FPGA. What about FPGA design? Initial cost will be less, because in the initial cost, what happens is someone is already giving you some basic hardware. Someone is already giving you basic hardware. On that, they are telling you, you program this hardware as per your requirement. You do the programming. You don't need to start from scratch.
Means we don't need to put transistors in
place and everything. You just have to program them to behave like the way you want.
You can just sit on the computer and
yes, do something like that. Yeah. Since hardware is readily available. But per chip manufacturing cost will be more. I mean, you have to manufacture each board separately. There we were going for bulk manufacturing. In FPGA, each one has to be custom made. So there it becomes more costly. So the difference is about initial investment.
But you said per chip manufacturing. It is already available if the chip size
No,
is already
not chip. You don't have the chip. You have it available like a board, FPGA board.
okay.
That to manufacture
board is available and all we do is
programming. But that board you have to buy, right?
Yeah, but if you buy a lot of boards, would it be like
Not like that. Someone has to still manufacture the board, right?
Yeah.
That
They
cost
will
of
be adding their cost.
yes, that cost of that board itself is high.
Middleman gets added.
Not even middleman. The cost of the board itself is costly compared to individual chips. Okay. So in summary, what happens is, since the initial investment is high, if you want to go for bulk manufacturing, let's say mobile phone, does it sell in hundreds or million lakhs? Lakhs. I go with ASIC. Let's say some hardware that goes into aeroplane. How many we require? Hundreds or lakhs? Hundreds or maybe thousands max. Because you maximum manufacture thousands of flights. That's all, not more than 10,000s, right? In that case, they go for FPGA. If you go to Boeing or Airbus, they don't use ASIC there. They'll use FPGA. Because for them, that initial multi-million they don't need to start, they don't need to manufacture millions of chips, right? They need to manufacture only few hundreds. So they prefer using FPGA for it, because even per chip cost, even if it's higher, that's fine for them. Reason is they don't have to invest multiple $1 million to develop the flow. This is the graph looks like. What is X is the number of units you manufacture. X is what? Number of units that you want to manufacture. Let's say, do I want to manufacture 1,000 chips? What is my final goal? Will I be manufacturing 1 lakh chips? 1 lakh chips. Y axis is what? Total cost. This is total cost. X axis is how many chips you want to do. Blue line, the thick blue line, is the FPGA line. Okay. The light blue line is the ASIC line. So initially, to start with, even if you just start with one unit, ASIC will be costlier. But as you start manufacturing more units, the ASIC cost will be like this. It will be little, no, ASIC cost will be little slant like this. FPGA will be, so this is the point where if I draw this line here, to manufacture, let's say 10,000 units, 10K means 10,000 units. FPGA is more costly compared to ASIC. But here, if I draw, let's say I only want to manufacture 200 units, which is higher costly? ASIC is costly, FPGA is cheap, because FPGA cost is only this much, ASIC cost is high. So this is the critical number. This can be 1,000 or anything. Okay, this is the number where that I decide. Let's say I am the company who want to develop a hardware. I can develop my hardware both the ways. I can develop using ASIC. I can develop using FPGA. Now I want to decide which one should I go with. What is one question I will ask? How much quantity do I have to manufacture? Do I have to manufacture 100? Do I have to manufacture 1 lakh or 10 lakhs? Then I will do some basic mathematics. What is my initial cost? How much I have to initially invest in setting up the flow? Okay, I'll do simple calculation. I will decide where do I fall? Do I fall here? Do I fall here? If I fall here, which one will I go with? FPGA. Because FPGA will be cheaper for me. ASIC will be costly. See, this is bigger than this one. Whereas if my line falls here, my point falls here, so I'll go with what? ASIC, because ASIC will be cheaper. In both the approaches, you are manufacturing same behavior. Finally, it will be the same working phone only. But these factors decide.
Is cost the only thing that is?
No. There are multiple things we'll discuss. Okay. Any VLSI chip can be developed in either ASIC or FPGA flow. Decision is based on cost. One of is cost, and there are other things. I gave you an example, right? Just an example. ASIC based chip may cost $15. The FPGA may cost around $40 to $50, possibly, right? Which companies go for ASIC production? Companies which manufacture for bulk, large quantities. Like mobile phone is an example, laptop is an example, right? If you go to Intel, which technology do they use to manufacture chips? They will use only ASIC. ASIC style of development is preferred. Companies goes for FPGA production. Companies which manufacture for limited application. Let's say in our college, there will be some oscilloscope, right? Do you think will it be used in houses? No, right? It's very limited use, right? In that case, what technology they'll use? They'll use FPGA board inside that. Hardware used in flights or in any educational purpose, they'll go with mostly FPGA kind of things. Then when you talk about colleges, right, BTech college and all that, why do they only teach FPGA boards? That initial investment is very less. In FPGA, how much is the investment? 15,000, you get one board. In ASIC, to set up that entire flow, you may need 1 crore rupees. The college itself may need multiple lakhs or multiple crores of rupees to set up the flow, to buy the tools and lot of things. For that reason, colleges don't teach, they prefer to teach FPGA. Not that industry is doing all FPGA, because for college it's more easy to teach the things to you. Can you read this once? What is ASIC? ASIC advantages. Okay, it is cheaper. Okay, consumes less die area because you are, like I said, right, we are building our own custom house customized, so we'll use the area very well, right? Hence, because it uses less die area, it will be cheaper, provides flexibility to customize the design features, and it is power efficient. And ASIC can work at higher frequencies compared to FPGA, hence gives better performance. See, what I build from scratch will be more efficient compared to buying modular units and putting, right? Even in the house construction, this house is more stronger than buying some units and integrating. It doesn't mean that only ASIC has all advantages, even FPGA has some advantages. See, FPGA, if you talk about a chip, if it has got some wrong behavior, wrong behavior, which is detected after manufacturing, FPGA style won't incur big cost because one board only you have to waste. Only one board is gone. We don't have to implement the entire flow again. Bug can be fixed in next FPGA board. We don't need to start from scratch. In ASIC, if there is a bug, we need to do entire flow again. FPGA flow is quick. Since we don't start from scratch, the board is readily available. It takes less time to develop FPGA flow compared to ASIC flow. In fact, see, in FPGA, flow will be quicker even if there is a bug, some mistake is there. Only one board is wasted. You don't have to waste all the boards. In the next version, you fix it, and in the new board, you use the new logic. Even in ASIC flow, they will use FPGA to initially prove the concept. Let's say I'm developing mobile phone chip. First, what I will do, whatever my logic is there, I'll put onto the FPGA board. I'll prove that FPGA board is working. Then I'll go for ASIC production. So that is called as FPGA prototyping. Is used to check the design behavior before it is manufactured. In FPGA prototyping, implement ASIC logic onto the FPGA board and check the behavior. Any issues in design can be figured out before going for ASIC production. I think this we can skip. Here I'm just talking about the cost factor. The idea is not to go too much deep into it. All we want to understand is that
Everything has advantage.
yes. Basically, the VLSI consists of two streams. One is ASIC, one is FPGA. Okay, even coming to the job roles, there are two job roles are there for you. One is the ASIC specific job roles, one is FPGA specific job roles. Both will have opportunities, but as I said, more opportunities will be into ASIC. Does it mean that everyone should select only ASIC? No. In FPGA, what happens? Number of people who join the training is also very less. So FPGA don't have that disadvantage that less jobs, because it has got lesser jobs comparatively. Very few people take training.
But while learning ASIC, it also includes the FPGA part, right?
No, FPGA needs some specific level of training. When you are doing that timing closure on that board, you are doing. See, we haven't discussed the entire flow, right? Means I told you there are 15 steps in the entire flow. At some stage, ASIC and FPGA will differ how we do the planning.
So that means the one who's doing ASIC, he has to do some sort of extra thing to go
For
to
FPGA, yes, and vice versa. Someone who is into FPGA also has to do some different things to get into ASIC. Fundamental concept is same. You're still manufacturing the hardware only, but the way you approach the things will be different, because in the second one, you are manufacturing you have the hardware, on that only you have to do all the planning. Okay. See, that is what we are discussing here. Yashes, you have any question?
Yeah, I just have one query related to the example which you have given for the advantages.
Yashes, do
So,
you have any question?
can you hear me?
So
Am
as I
I audible
said,
to you?
the VLSI design flow, I said two domains, right? One is front end domain, one is back end domain. See, the front end domain flow is similar for both ASIC and FPGA. What we do in the front end domain. Now, what exactly is the front end domain? We'll discuss in the next slide. And what exactly is the back end domain also we'll discuss. In both the cases, either ASIC or FPGA, user needs to understand the design specification. There will be one document called as design specification, which talks about how design should behave. Implement the design using both Verilog and using Verilog or VHDL languages. The functional verification of the design behavior is using SV and UVM. The functional verification is implemented using SV and UVM. Okay, we'll discuss. Okay, what is functional verification? We'll discuss going forward. Okay, so the point I'm trying to tell is the front end domain consists of these steps, which is same for both ASIC and FPGA. So where do ASIC and FPGA differ? If I ask, I am a ASIC engineer, you are a FPGA engineer. Where does our skill set differ majorly? It differs in the backend domain. Majorly it differs in the VLSI backend domain. So in summary, the VLSI design flow is two things: VLSI front end domain, backend domain. This is similar in both ASIC and FPGA. This differs in ASIC and FPGA. Why it differs is in ASIC you are doing from scratch, you don't have anything. In FPGA you have to do the domain backend flow for a board which is already available to you. You don't have any customization. Someone is already giving you, this is your area. In that only you have to plan. You cannot do any customization. You cannot tell that this door I will move there. You cannot do that because the room itself is coming as a prefabricated structure. So when you want to do some implementation, you cannot do any major changes in FPGA. But in ASIC, this room I can keep here. If you feel that it is fine to keep the room door here, I can move the door to here. That entire customization is possible in ASIC. So there, because of that, the backend domain.
Does FPGA, like as you give example, comes with chair, table, fans, electricity, everything?
Something like that, yes.
We can just move the chairs from here and there.
Something like that. Yes, you can customize. Okay, fan, how much speed it should rotate. That you cannot change the fan type also.
Okay.
Already they have given you one fan model. You can just change its behavior, how it goes.
You can't add anything, right?
Yes,
Add anything.
you can't add. What is that backend domain flow? The flow starting from physical design to custom layout. These are multiple stages. That is where they differ. The way we do the floor planning, I told you, right? In FPGA, it is fixed. Your floor area is fixed. You cannot do any change. In ASIC, you can choose how much floor area you want. Do you want to allot 200 square feet? Do you want to allot 150 square feet? That planning also you can do in ASIC. That is floor planning, placement, power planning. See, in the ASIC, in FPGA, what happens? This table, they are kind of keeping it here only. You cannot move it. Whereas in ASIC, I can move this table to that place, all that. That is called as placement. Power planning, clock tree synthesis, routing, timing closure is how it is done differs in both ASIC and FPGA. So in summary, VLSI design flow consists of two aspects: front-end domain flow, back-end domain flow. Front-end domain flow is kind of similar for both ASIC and FPGA. Back-end domain flow is where ASIC and FPGA differs. Let's now talk about the ASIC design flow, because our training as of today is focused on ASIC design flow. Okay. To understand ASIC design flow, let's take one simple analogy. We'll take an example of a house construction flow. Where does house construction start from? it starts with the requirements, right? What do you need in the house? Do you directly start with foundation? No. First you ask, what is my requirements of the house? What kind of house do you need? Then whom do you go to? Once you have the requirements, whom do you approach? Architect, house architect. What architect will give you? Different types of plans. He will ask you what is your requirement. He'll give you architecture diagram, different types of plans, electric plan, plumbing plan, everything, right? Then whom do you go to? Either contractor or some maestri will go. What is that he will take? He will take all this as input. Whatever plan you got from architect, it becomes input to the contractor or maestri. What is the output? Building structure. Is your house construction completed? No. He has done till basic structure. What is that you still have? Flooring, painting, plumbing, electrical work. So you go through all the stages by the time your house is constructed. So what is that we are trying to draw analogy here is that house construction is not done by one person. There are almost 10 to 15 people involved at different stages to complete the house construction. Can electrician do work before floor planning? I mean the foundation. So there is a specific order you have to follow, right? You know, right? So you can't even change few order also. Means you can't put tiles before electricity. So there is one exact order we have to follow. Even in the chip manufacturing, exact flow is followed. Let's take house construction example. Some architecture, some decision is went wrong. Instead of placing the pillar here, somewhere else they have placed. What happens to the house?
The
whole house is gone, right? So even if you do this entire flow, finally you decide that you figured that someone came and said that you have kept the pillar at a wrong position. Structurally, it is wrong. What I mean, will you stay in that house? That's a problem, right? Same thing happens with the chip also. If some fundamental mistake happened in the chip at any stage, then entire chip is gone. Even while manufacturing, you have done something wrong. So in case of house, it's only one house. In case of chip, what is happening is we are manufacturing some millions of chips. Even if the whatever mistake is there, it will come into every chip. Then every chip is waste. So that is where at every stage of the chip design flow, there will be some type of verification. At every stage, they'll keep doing some checking just to confirm that everything is going fine.
That's why you told us that FPGA prototyping we do.
Yes, that is one of the things why we do FPGA prototyping also, right? So with this understanding of construction analogy, let's take ASIC design flow. ASIC design flow also consists of around 15 steps. It consists of 15 steps divided into two major categories. One is front-end domain, other is back-end domain. See, like our house construction has around 10 to 15 steps, like plumber, painter, electrician, different. Here also we have got different people doing that work. Can I ask painter to do plumbing work? No, right? Each one has one expertise, right? Because painter has his own expertise, plumber has his own expertise. Same way in ASIC also, I cannot ask physical design engineer to do DFT. I cannot ask a DFT engineer to do design verification because their expertise is different. Same way, that's why in VLSI, since so many steps are there, to do so many steps, should we go with one person or different people? Different people. Like in house construction, will you have only one person do everything? Electrician work, plumbing?
Even if he knows,
We won't, right? Same thing happens in ASIC also. Companies don't expect you to know everything. Companies don't expect you that you should be expert in FPGA. Sorry, you should be expert in physical design. You should be expert in DFT. You should be expert.
But so many people are doing one work. Accountability comes better in if one person is doing each work. If there's some problem, the company can say you are the sole responsible. You are responsible for it. But in different persons, every person will say, okay, I'm not responsible. He was responsible.
No. You know, right? Who has done that work?
Okay.
You know that, see, this work was done by whom? Let's say architecture, something wrong in architecture. Whose mistake is it? Architect. You know that architect has done the mistake. Let's say something wrong went in design coding. When we have implemented Verilog code, see, in the RTL design, what do you do? Whatever architecture you have, that gets implemented in Verilog language. Something wrong in Verilog language. So that mistake will be both design engineer and functional verification engineer. See, there is someone called as functional verification engineer who is supposed to catch those mistakes. As a verification engineer, I am supposed to catch the mistakes done by the design person. Okay. So if something is missed, so it's a mistake of both design engineer and the verification engineer. Okay. So what is RTL design? I told you that each block, the behavior is implemented using Verilog language. How that block should behave, that is implemented in Verilog language. Then finally it is integrated, means put together everything.
Different blocks and then
Integrated, yes. Then finally we do the RTL functional verification. Functional verification is what? Checking the behavior whether it is working fine or not. Let me show you one simple example. Let's say in this is one of the design Verilog code. For example, somewhere in this code, some mistake is done. Instead of AND gate, here what is this gate? Ampersand, right? This is AND gate. Instead of this, by mistake, someone has put OR gate. That line means OR gate. Okay. Now tell me, where is the mistake? In a very bigger picture, how many files are there in this code? 30 files are there. How many files are there? 30 files. Now, which file have done mistake? Looking at the code, can you tell me where is the wrong thing? Okay, I will show you this code only. Where is the mistake? Is it possible to tell where we have done the mistake? No, right? Because you don't know the intention of why he has put OR gate, why he has put AND gate. We don't know, right? Looking at the thing, you don't know. So for that purpose, we have to follow some process called as functional verification. One structured process we have to follow. As part of that, we develop some test cases for each feature. Okay. See, again, this terminology could be little difficult for some people who are just very new to this. Don't worry, we are not going to start again. As I said earlier, we are not going to teach everything like this only today we are taking a bigger level picture, that's all. Otherwise, rest of the sessions will start from the scratch level. Okay. So what is the role of a functional verification engineer? He finally is supposed to catch those mistakes, whatever mistakes that happened intentionally, or sorry, it won't be intentional, unintentionally. See, while developing the code, design person would have done some mistake. See, like I said, instead of putting this tilde, which is inversion, he would have removed. He may have missed out unintentionally. That is a mistake, right? Finally, what will happen? This mistake will come into my mobile phone. Actually, somewhere that mistake will come into my mobile phone. That mistake will not show every uses, every time it won't come, but in some times that mobile phone will start behaving wrongly. It's like out of 100 times, 80 times it may work fine, but 20 times wherever this specific thing comes into, this gets called, my mobile phone won't work properly. Will I use that mobile phone? No, right? So in that context, the role of a functional verification engineer is to find these kind of mistakes. So to find the mistakes, he doesn't go through each line. He won't tell, is this line correct or wrong? Is this line correct or not? That's how I cannot do it. We follow some process called as list down the features, figure out what you want to check. In that feature, what you want to verify. create some inputs to the design, apply the inputs, check the outputs. If output are the outputs coming as per my expectation, okay, let's say this is my design, I apply some inputs, I'm getting outputs. Is it coming as per my expectation? If it is if it is coming as per I am thinking, then it is good. Otherwise, something bad. Then you trace it and figure out, okay, here is the mistake. You have to actually reach that point where you have done the mistake. See, let's say you have done mistake here. This is where the mistake happened. You have to catch that somewhere here there is a logic wrong. That will be the role of a functional verification engineer or RTL verification engineer or ASIC verification engineer. You use any term, functional verification engineer or RTL verification engineer or ASIC verification engineer. Everyone is doing the same work. Or design verification engineer. Means we may use different terminology, but everyone is still doing the same work. You got what is the role, right? Means the point is, for some reason my design is not working. It is not possible for me to go and tell that this file has a mistake. In this file, line number 110 has a mistake. Can I directly tell? That will happen only if I have some magic.
Or either you can execute, each and every, and it will show non-executable.
No, not like that. It's not like that. Everything is executable only.
Okay.
Everything is finally Verilog code only.
Something will show in red, right?
No, nothing like that. It won't show anything red. You have to create some scenario. It's like you have to create some scenario, some input pattern. Different inputs you have to create. For every input, you will get different outputs. That output you check against expected behavior. Okay, it's like simple. You're checking some addition operation in the calculator. You'll give 2 and 3. What is you expect? 5. So in your brain, what you have? 5. So 5 and 5 is matching. So fine, calculator is working fine for addition. Same thing you're doing here. Though we took a very simple example, but to check addition, what will you do? You'll enter a couple of numbers and keep checking whether the output is coming fine or not. Okay. Something similar you're doing. You're going to apply few inputs. It will give you output. You as a verification engineer,
Should know the result before.
yeah, that is called as, there is something called as reference model. You create your own model of the design. You create your own model of the design called as reference model. Whatever input you are giving to the design, same input you give to the reference model. This will give you expected output. This will give you, design gives you actual output. Design gives you what output? Actual output. Test bench gives you what? So reference model gives you what? Expected output. Let me again tell you what is reference model. Reference model is the model as a verification engineer I have developed. Who developed design? Design engineer. Let's say he is the design engineer. He developed and gave me. What is my role? To check whether he has done the work correctly or not. To check. He is the design engineer. I am the verification engineer. He developed the design using which language? Verilog. He has given me the code. Now just looking at the code, going through each file, I cannot tell whether this code is correct or not. It is not possible. So how will I verify his code is correct or not? I will take his code. I'll develop my own model. What is that called as? Reference. It generates a reference value, reference model. Whatever input I give to the design, I'll give the same input to reference model. I'll give same input to reference model. I'll compare actual output and the expected output. That will tell me if both are matching, then it is fine. If they are not matching, there is something wrong.
What is the need for engineer? You made all those, and you also made reference model.
Yeah.
You have already made. Why did you make a whole reference model? I, as an engineer, also made a reference model. You also made a reference.
No, you didn't. You used Verilog. I use a high-level language. My model will be very high level because your code should be manufactured. Your code should become a chip. My code need not become a chip. So I'll use a different language.
That will be easy to program.
That will be easy to code. I'll use SV and UVM, languages like System Verilog, UVM, whereas this has to be strictly Verilog. It has some restrictions because it has to finally become a hardware. But my reference model need not become a hardware, so I can use anything what I want. Okay. My final goal is simple. If there is any mistake anywhere in the design, somewhere there's a mistake, I have to identify what mistakes are there in that. I have to just identify what mistakes, and I have to report to you.
This is the mistake,
correct it. This is where somewhere some wrong behavior is there. You will tell no, that is not a. If you think that that is correct behavior, you will tell me what? No, that is your wrong understanding. My code is only correct. Or if you have done some mistake, you will tell me that okay, this mistake I'll correct it. You'll fix the code. You'll give me in the next version. Next version of the design, you will give me the updated code. Again, this process keeps continuing till we find till everything is working fine. To measure when is my work completed. See, will I keep verifying for 1 year, 2 year, 5 year, 10 years? Why can't I keep verifying for 5 years? Because mobile phone has to keep coming every year, right? What is the Apple version this year? 17. Next year? 18. Right? Can they release after 5 years? No, right? That iPhone 18 chip has to get verified in some limited time, right? Only then 18 can come out next year. So for that reason, what is a measure for me that my work is done? That measure is called as coverage. We have some measure called as functional coverage, code coverage. If I hit 100% functional coverage, if I hit 100% code coverage and all my scenarios are passing, 3 conditions. What are the 3 conditions? All test cases are passing. It's like one scenario applied is one test case. If I verify different features, so I'll develop multiple test cases. Just to give you an example, in laptop, keyboard is one feature, USB is one feature, Ethernet is one feature. So to verify laptop, I'll check each and every feature, right? I'll check each and every feature. Same way here also I'll check. So I have 3 criteria to say my verification is complete. First criteria is what? Every test case I developed, it should be passing. Second, I should get 100% functional coverage. Third, 100% code coverage. Functional coverage, code coverage. Then I know that my work is completed. Then the code goes to the next stage. Because now I have you wanted my help in verifying. Why you wanted my help? Because if you only develop the things and if you only verify, what is the problem? Whatever mistakes you have done, you will be, because you have a wrong understanding. Why you have done a mistake? Did you intentionally do? It's like you wanted iPhone 18 to not work properly. No, right? You unintentionally you had a wrong understanding. You were reading through some document. You had a wrong understanding. That wrong understanding has gone into the code. As a verification engineer, what is my role? To double check your understanding, to figure out that what you have done is either correct or wrong. We go through that cyclic process where you fix and give me, I again verify everything and I tell you, okay, this is still there.
But sir, these functions can be done by the engineer also. Like he can also make a SP sort of testing.
Who you?
Yeah.
Thing is, that's why the problem is you already has a wrong understanding. Same wrong understanding will go here also, right?
Okay. But SP said you said it's a
not about. It's not about language. It's about understanding itself is wrong. Your understanding itself wrong. The wrong understanding went into design. Same wrong understanding will go into SV also, right? Then what will happen? This is also wrong. This is also wrong. Both will match. So as a verification engineer, I'm not going to take your inputs. I'll follow my own process, and both outputs will compare. That doesn't complete our chip. That is what happens in the software. In software, that's where the work stops. I'm a developer, or you are a developer. You develop the software. I'm a tester. I have tested your software. Done. Now it will go into production, and production means what? Actual deployment. Whereas in hardware, next starts the major process. That entire process is called as back-end domain. What we did till now is called as front-end domain. Let's again repeat. Whatever we did till now is called as front-end domain. Means in the company there is a marketing team. You go to Qualcomm. They asked, our Apple is the best example. In the Apple there is a marketing team. They figured, okay, 2027 we want to come out with iPhone 18. What will be the requirements? What kind of camera? Okay, how many megapixel camera? What kind of display? What kind of storage? Everything. That marketing team goes to architect. They will tell, this is our requirements. As per that, you develop the hardware. What architect will do? What architect will do? He'll draw this kind of diagram. He'll draw this kind of diagram. What we call as the SOC architecture. I mean, this is just to show it. He will give you more details only. I mean, very fine details also. He will tell everything about each and every connection. What is the clock? What is the frequency? So many things. Okay. This becomes input to whom? Design engineer. Let's say he is the design engineer. He will take this entire document, and there will be one more document called as design specifications. Based on that entire understanding, you develop Verilog code. What is the Verilog code you have developed? These files. See, V file is what? Verilog file. So these all files you have developed and give me. I'm just showing you one simple example. My role is what? Have you done your work correctly or not? Who am I? I am a verification engineer. So what will I do? I have to follow some process. See, I don't have a magic where, okay, I will open this and tell this code is line, this line is correct. I don't have that power. I don't have that magic power to tell that whether line is correct or wrong. I have to follow some process. That entire process is called as functional verification flow. That itself involves around 10 steps. I have to read the document. I have to figure out what to verify. I have to figure out how to verify. Then apply some inputs. Okay. So for that purpose,
Seems like architectural is very different.
yes. Okay. So if you look at it, okay, architecture is done by people with 20 years of experience. This is what, as a verification engineer, I will develop. Okay. This is the design he has provided me. DUT stands for design under test. So this code, who has provided me? He provided me. And rest all things you see is developed by me. Who am I? Verification engineer. This diagram is called as what? Test bench architecture. Okay. So as part of this, not to go deep into each of them, my role is simple. I'm applying some inputs by means of some generator and BFM. Same thing is collected by the monitor, given to reference model. This is giving out what? Actual output. This is giving out what? Expected output. I collect the actual output. Both are given to whom? Checker. Both are given to whom? Checker. The checker will tell whether it is working correctly or not.
Checker is comparison.
Comparison. Some kind of comparison. Comparing the expected behavior with the actual behavior. That whole thing is tracked in the scoreboard. Like in cricket, we have a scoreboard, right? This many wickets, this many overs, this many runs. Same thing here. I mean, it's not the wickets and runs here. It's like how many scenarios created, how many passed, how many failed, what failed. That kind of scoring, that information will be kept track
It
of.
also shows what failed.
It will tell it failed. You have to finally figure out why it failed. Has it failed here? Has it failed here? Somewhere it went wrong, right? Our mistake could be in my model. See, your model may be correct. My model could be wrong. So I have to, as a verification engineer, my work is that. So that is called as debugging. Simple, right? Debugging means what? Figuring out where is the mistake, right? That is where we spend almost 70 to 80% of our time. Once you get into the job, our work won't be on SV and UVM. Our work will be on debugging what went wrong. So that patience is what is required. You understand that you need patience, because out of these 100 these files, anything will be wrong. Now, how will you figure out where it went wrong? So the training prepares you in that direction. But then you may ask, why to learn SVM? Why to learn SVM? Because you learn system Verilog and UVM languages. Okay. But once you get into the job, your actual work on SV and UVM, it is more into these kind of issues. Something went wrong. What went wrong?
Does the company provide this sort of verification, like something?
It's not a software, it's the architecture we develop. We have to code all these things. We have to put together everything, all that.
The company doesn't provide this.
Company provides something called as simulators. The simulators you have to use and run them, and through that you have to take the help. You finally got the what is the role as a functional verification? You as a functional verification engineer, your role will be somewhere in the design some mistake is there. Let's say that cross is the mistake. You should have created a scenario which will actually go. Let's say if this scenario goes, you catch the mistake. No. Your scenario has to be such that it has to traverse through that path, then that mistake will come out. That path has to hit, right? Path has to hit. Let's say in my mobile phone, camera has a problem. Camera has a problem. Will you figure out the mistake while doing a mobile phone call? Let's say you are just calling, you are sending SMS. Will you find the mistake? No, right? Whatever amount of calls you do, whatever amount of SMS you do, you won't catch that mistake. So you will catch that mistake maybe during some video call. So your scenario should have been what? Video call should have been the scenario. So the functional coverage is the one which checks all those things. Functional coverage will ask you, have you done video call? So functional coverage is like a questioning. Have you done video call? Okay. Have you done SMS? Okay. Have you done direct mobile call? Have you done data transfers? That concept is called as functional coverage. Functional coverage is like a guarantee that, okay, these were all the minimum things you had to check. Have you checked all those minimum features? Similarly, there is one more term called as code coverage. We'll discuss later. Okay. But coming back here, what was my goal? That black cross is the mistake. So to find that mistake, I apply some input which will go through that black mark. Because that black mark is wrong, my behavior will come wrong. See, from here, the wrong behavior will come out. That I will collect. My here comes a good behavior because my understanding is right. So I will catch the mistake. But I really don't know that this black, where is the black cross? I don't know. All I know is some comparison is failing. What is that I know? Some comparison has failed. All I know is some comparison has failed. So then what will I do? I have to go through the different paths. I have to go through different paths. Now that path could be here, different paths. Finally, I have to reach here. How quickly I can reach is my ability. So what is, as a verification engineer, my expertise? Can I reach that in 10 minutes? Will I take 1 day time? If I can reach in 10 minutes, you're like very good verification engineer. If you take 2 days means it's bad. So that's about how quickly you can do. So to do that, we get some softwares. Completely manually, you don't have to check every line manually. There are some softwares like Synopsys tools, Cadence tools, mentor graphic tools. Like in Synopsys, we have tools like VCS, Wordy tool. They will help me do the decision making quickly. They'll help me, okay, it will help you, okay, you have to take this path. They'll give me that suggestions. I can see the values and figure out, okay, from here the mistake is coming. But do you think tool can do entire work? No. My intelligence is required, right? For this purpose, I told you this is actually the final goal. This is the final goal of this training. To become a good verification engineer. What is good verification engineer do? Ability to catch the mistakes quickly and with a proof. With a proof, you cannot randomly. I cannot randomly go tell this line is wrong. What is that? He will ask. What is the proof? The proof is what? This test case is the proof. See, I'm running this test case. When I apply this input, my expected actual output is mismatching. Then he got a proof that okay, this is the mistake. So he will correct the mistake. So I have to find the mistake. I have to tell him this is the scenario where it is behaving wrongly.
Why can't just you correct the mistake? Why
I don't have authority because I have to confirm from you, right? Because your understanding may be correct, my understanding may be wrong. Your six can be mine. Sorry, I'm just taking right. My point is what? Your understanding could be right, my understanding could be wrong, and I mistakenly I have given you wrong bug. Actually, which is correct, I have reported as a wrong thing. So finally, you have to confirm all that. So that entire process is what is the functional verification.
So it's not mandatory that you if it's wrong then okay sir. It's
No, not like that. You have to. You will
discuss with you.
you discuss and then you tell me whether it is correct or not. Okay. That is the entire process we go through. Okay. So let's briefly summarize. Okay. I was telling you that there are two domains: front end domain, back end domain. Front end domain consists of all the steps. This is very similar to software engineer. Very similar. This is what is new in VLSI, which is not there in software. This is from this point onwards, manufacturing starts, means you convert it into gate format, you fit it into one fixed area, die area, that entire process. If you are interested in that you can attend tomorrow's session. It's how the physical design happens, how the DFT happens, how the STA happens, that entire thing. Talking about front-end domain flow, I said that front-end domain flow is similar to software flow. Software engineer skill set is what? C, C++, and Java. They should be good at reading the software specifications and develop the algorithms and implement the same using different languages, right? They should know how to implement algorithms in C language or C++ or Java. They should have good programming skills. Coming to VLSI front-end domain engineer, same like we have C, similar to C, we need to know Verilog. Similar to C++, SB. Similar to Java, UVM. They should be good with programming and have inclination towards programming. I mean, okay. Reading, they should be good at reading the documents, that is called as hardware specification, design specification, and understand the functionality. Means there will be some documents will be there.
The document which the architect is provided.
Yes. Some documents will be there, what we call as design specification. Plain English, yes. Which talks about everything about how the design will behave. It's like they're giving the complete details. You can see what is the architecture, what all components will be there, how they behave, everything they're talking. So right now, for example, it's 50 pages. Some documents could be 1,000 pages. I mean, depending upon the complexity, they could be 50 pages, 200 pages, or 1,000 pages. This is what we call as design specification. So the design specification is input to me also, to you also. See, as a design engineer, for you also it's an input. For me also it's an input. You are developing design code. I am developing reference model. We are just trying to validate both of them. That is what I meant by should be good at reading hardware specifications. What is hardware specification? This kind of document, and understand the design functionality. And finally, implement the behavior of various protocols. I need to learn some protocols, how USB protocol works. Because at hardware level, how does the transfers happen? Through USB, through DDR, that level of protocol understanding. Where does it differ from software? We have till now we have seen the similarities. Now let's understand what is the differing. Software doesn't have backend flow. In software, do you manufacture a software? All right, you directly deploy the software. You go to a bank, they would directly use the software. They don't get a chip of a software. In backend domain flow, the process of converting the Verilog code into a chip. In software, the code is installed and used, no need to manufacture as a chip. In VLSI, the functional verification plays a very important role. If there is a bug in the chip, for example, in my chip has a bug, then all the chips will be faulty, which is detected once it is in production. Let's say once it went into the production, you find the bug. Then the bug cannot be fixed, right? Okay. Let's say something wrong in my hardware. Can I fix it now? All right. This entire phone is waste. Not only one phone, all these models of this phone are all waste. So the entire flow needs to be done again. See, again, to fix that issue, I have to go through the entire flow and fix the phone issue, which will be very costly. Okay. In software, if there is software, they have to just release a patch. It can be fixed and released as a new version of the software as a patch. So you don't have such a major cost. At max, what happens? Something wrong happened. They can reverse that behavior, and they will release a patch, and new software will get released. But in hardware, there is no concept of patch. You understand? In hardware, there is no patch. You cannot fix a patch and make it work. A verification engineer has more responsibility compared to a software tester. Both are doing same work actually. Software tester is finding the bugs in the software. Functional verification engineer is finding the bugs in the design. But I have more responsibility because anything I miss, it will lead to very high cost because it cannot be fixed afterwards.
We see cars getting called back to the
Yes.
manufacturing company due to some
Yes,
problem.
yes. All those things actually. The chip may be wrong. They may replace that chip completely. All that.
If there's some problem in like car chip, then they just say, okay, we just will do update. Come to the service center and we'll do update.
Yes.
But if there's some problem that's lost or some chip,
Yeah.
some problem, then all those cars get called back.
Yeah,
There's a
exactly,
very
same
big
thing.
issue.
So this is about what is VLSI, what is front-end domain flow, what is back-end domain flow. We did not go into back-end domain flow purposefully because it'll require another half an hour, 1 hour to discuss what is physical design, what is DFT and all that. Okay. Let's now talk about different job roles in VLSI domain. Everything is like a job role. You take an example of house construction, painter is a job role, plumber is a job role. Here also same thing exactly. Everything is a job role. Design requirements is done by marketing team. The person who does architect is called as chip architect. The person who does RTL coding is called as RTL design engineer. The person who does integration is called as RTL integration engineer. Person who does RTL verification is called as functional verification engineer. The person who does DFT at RTL level is called as DFT engineer. DFT, design for testability. We'll discuss briefly what is DFT. Like that, everywhere you see person who does synthesis is called as synthesis engineer. Just add engineer in the end. That's all. Formal LEC engineer, DFT engineer, physical design engineer, everything. So in summary, idea is not to confuse you with so many terminology. Idea is not to confuse you with so many terminology. Idea is that there are almost 12 to 15 job roles are there. Different job roles are there. I can be a DFT engineer, I can be a physical design engineer, I can be a STA engineer. So different job roles are there. Like in the house construction, you have a painter, plumber, each role is different. In the chip design flow also, each step is different, and there is a specific engineer who works on that.
But in the front end role, okay. So I don't think a fresher can join as a chip architect because he requires a lot of.
That's what we'll discuss that also now. We'll discuss. Okay. So if I take an example of a one mobile phone chip, let's say you go to Qualcomm, they are working in a mobile phone chip. Let's say that team has 50 people. Around 25 to 30 people will be into front end domain. Remaining 20 to 25 people will be into back end domain. See, there are only two domains, right? One is front end domain, back end domain. So little more into front end domain, little less into back end domain. Out of them, can you see the further distribution ones? How they are distributed in individual? So you see, front end domain requires little more people. Out of them, only one architect. You want to construct a house, do you go to 5 architects? No, right? One good architect. Design team will have less people, 4 to 6, lesser people. But where do you have more people? Because in design, what happens is we reuse the models. Let's say I want to develop a processor code. I don't develop from scratch. From Qualcomm, I don't develop from scratch. I may take the model from ARM, or I have existing things. I will use that existing things. But when it comes to verification, whatever be the case, I still have to verify every behavior, because even though it is existing model, what if something is wrong at integration level or anywhere it went wrong? You cannot tell that. You cannot blame anything. Finally, the chip is wrong, the whole thing is wasted. So hence, companies give a lot of importance to functional verification. They spend a lot of resources on functional verification process. Similarly, in the backend domain, so that's, see, in the front end domain, that verification consists of almost 30 to 40% of entire team. Your entire team is 100 people, up to 30 to 40 people will be functional verification only. In backend domain, there will be around 20 to 25. DFT will be anywhere between 2 to 5 people. Physical design will be 10 to 15. STA will be 3 to 5. Layout is 3 to 5. See, we kept a range because it can be anything. It's not always rule that it should be 2, it should be 3. It is as per the team's requirement. But where do you generally have more requirements? Functional verification, physical design engineering. These are the two domains where you have more requirements, and that is what you see in the companies also. Even in the training trends also, you'll see more people into physical design and functional verification. Okay. Does it mean that DFT don't have any jobs?
As a beginner job.
Yeah. See here, what happens? Since there are 15-20 people, companies, what they can do, they'll keep 10 experienced people, 5 freshers they can keep. They can keep some freshers because number is big. But do you think architect can be fresher? No. Even here, if you take 4 to 6 people, here also companies don't take a chance. They mostly go for experienced people. Again, DFT can be an exception. There are times where companies prefer hiring freshers also. Right now also we see companies preferring hiring freshers also. Okay. Maybe there are times where you need more DFT engineers. That's where they also go for freshers. Okay. So out of these things, there are 4 domains where freshers gets hired: functional verification, DFT, physical design, layout. These are the 4 domains where we have generally seen better hiring for freshers. So you got the idea, right? Now, how do you choose which domain? We'll discuss going forward. Let's talk briefly about what is DFT. I've been using the term DFT right here. DFT at RTL level, DFT at gate level. What exactly is DFT? Let's try to understand. DFT is also like one way of finding the mistakes in the chip. DFT stands for design for testability. Design for testability. Let's say you take your mobile phone. For example, it is not working properly as expected. There could be two kinds of problems. The phone can have two kinds of problems. One problem could be because the person, the design engineer, let's say I'm the person who developed the Verilog code, I have done some mistake. Which is the Verilog coding I showed you, right? Some Verilog. While doing that Verilog coding, I have done some mistake. As a verification engineer also, he missed identifying. For some reason, he didn't identify the mistake. I have done Verilog coding. My code has some mistake. He didn't catch that mistake. Then finally, what will happen? It will come into my phone. That mistake will appear in my phone. That is the functional verification issues. Functional bugs. That is functional bugs. Second type of bug is I have done design code correctly. He has also identified all my bugs. No issues are there. Functionally, everything is correct. But during the manufacturing, you know what level we are manufacturing? 3 nanometers, 2 nanometers. What is nanometer? If I have to just give you estimate, you take hair strand. This is the hair. You cut it in that vertical manner. You cut it 1 lakh times. 1 lakh pieces you cut vertically, not like this. Like this, you cut 1 lakh times. What you get is nanometer level. What you get is, you can imagine, right? The hair strand you cut vertically 1 lakh times. Then what you get is nanometer level. At that level, what may happen? You're trying to see, even in the chips like we have in the house, wiring is there, right? Electrical wiring is there. From one place to other place, you're doing a lot of wiring and all that. In the chip also, in the dense area, you're doing too much wiring. Okay. Somewhere you are drawing two wires. They deposit some metal. They throw some metal. What do? Is they melt the metal, copper. Then they spread the metal.
On the nanometer scale.
Yes. Okay. At that scale, they
put the copper wire.
Wiring. What can happen? Some small shorting may happen.
Yeah.
Right? Is it our mistake? Let's say I'm design engineer, he's functional verification. Is it our mistake? What is the mistake? Manufacturing defect. It's a manufacturing defect. If I have done mistake, that is functional defect. Because functionality itself is wrong. If we both did correctly, due to the manufacturing, this mistake doesn't happen in every chip. Let's say if this is my wafer, I told you, right? Mysore Pak we cut. So out of this one, sorry, this may be good, this may be wrong. Because their mistake might have happened, but here the metal wires are proper. Here metal wires have some connection, some shorting happened. You know, right? In the house also shorting happens. Some two metal wires, they get connected, the shorting happens. Even in the chip it can happen. This is a faulty chip. This is a good chip. Now the question comes, I give you a chip. Tell me, is it good? Is it bad? How will you tell? How will you tell that this chip is good, this chip is bad? So then finally, will we wait for this going into the mobile phone? And then user comes back and tell, okay, you have given me faulty phone. And will I tell, I'll replace your phone? Are you getting? Faulty. And faulty. Which one is? So will I manufacture, still go ahead and make the mobile phone and sell it and wait for you to come back and tell me that this is faulty chip? That process of checking the chip post. So to do post validation, what they do is simple. They take a chip, they apply some inputs. You the expected behavior. If it comes as expected behavior, it is good. If not, bad. The person who provides those inputs is the DFT engineer. Someone has to provide those inputs, right? What inputs to be applied? How do I check? How do I confirm that this chip is good or bad? I have to apply some inputs. Yeah, physically there will be something tester. Like this table is the tester. This table is the tester. On my tester, I'm placing my chip. Yes. Then I start driving some inputs. Okay. The person who provides those inputs is the DFT engineer. The person who actually does the testing is the post silicon validation engineer. PS engineer. See, I told you everywhere add what? Engineer. DFT, who is the person who does DFT? DFT engineer. Who does functional verification? Functional verification engineer. Who does HTA? So who does post silicon validation? PSV engineer. Right? So the role of a DFT engineer is to generate those inputs. He will give those inputs. Let's say you are PSV engineer, I am the DFT engineer. Who is actually checking the chips? PSV engineer, you are checking. But to check the chips, what do you need? Some inputs, some vector, some patterns through which you are going to apply to the chip and then finally check the behavior.
Each and every chip.
Yes, everything goes through that process.
No, like if
every chip goes through that process.
1,000 chips are manufacturing,
yeah.
Every has to be tested.
Yes. That's why this is so costly. It has to go through that entire process. So for you to check that chip, what is that you need?
I need
Inputs. I am the person who provides those inputs. I have some process. See, like we did functional verification through a structured process. Like we did functional verification in a structured process. Even as a DFT engineer, I have some my own techniques. They're called as scan techniques, automatic test pattern generation, built-in self-test, JTAG, bond. There are some 7-8 techniques are there. Using those techniques, I generate some numbers, some 1010, some patterns. That numbers I give you. That you apply and you check.
So my role, because very easy,
it's not like very easy. Finally, you still have to check something went wrong. You have to figure out where is something went wrong. Okay.
My job would be just not to say, okay, it is wrong. Where it
it's
is wrong,
where is you have to figure it out and what went wrong. That also you have to do. So that is the what is DFT. So let's understand. Can you read it once?
One pattern for every chip, right?
Yes,
for
same pattern. It's not like one pattern. There will be multiple patterns.
Multiple. Like for every sort of testability that every path gets taken.
Yes, exactly. Yeah. So here what happens? Chip can have different types of defects. Means what is one defect? Some line is always 0 voltage.
Doesn't get high.
It will never go to 1. Is it correct? No, right? No. Sometimes it should be at 0, sometimes it should go to 1 based on what I give it. Sometimes it can always be at 1. So like that, there are different types of defects are possible. They are not our mistake. They are not due to design mistakes. Verilog coding was all correct. Due to manufacturing process, there could be mistakes. So there is a term called as yield. What is yield is, if out of 100 chips, if 95 chips are good, 5 are bad, then the yield is 95%. Simple. It's a percentage. How many good chips are there in the overall chips? Yes. So as a PhD engineer, you will say, okay, this chip is good, this chip is bad. So the DFT engineer develops the test patterns which help detect the manufacturing defects in the chip. Example, one test pattern can be what? 10, some provide numbers. This pattern applied to this output test whether the chip is good or faulty. DFT engineer uses needs to generate what pattern, what techniques he will use, scan, PPG, detect, boundary scan, compression, multiple techniques are there. These test vectors are provided to post-silicon validation engineer. The person is called as PSV engineer. What is the PSV engineer does? Apply vectors to table kind of thing. Where you have to think of the if it is from are there any manufacturing defects? If there are defects, it is not used for packaging. 100% percentage of good chips is called as yield. I told you, right, out of 100 chips manufactured, if 82 are working fine, then what is the yield? Is it good number? No, very bad number. So generally, as the process gets improved, we should reach 99% or 100% yield. Means what, every chip should get manufactured properly. That is what foundry will work on. They will work on improvising the process to get 100% yield. Let's say right now they are at 2 nanometer level. TSMC. They are, let's say, moving to 1 nanometer level. Their yield will be bad initially. Initially, their yield will be bad. They'll improvise the process till they hit that 99% like.
Because manufacturing a chip is like very costly.
Yes. Okay. I have already explained you this diagram. What is functional verification? Okay.
And the same question arises: why can't a DFT engineer do the same work as silicon verification engineer? He has all the inputs.
No. See, one work is like as a DFT engineer, I am doing the work at the Verilog coding level only. Still, the chip is not manufactured. So the actual validation starts after chip arrives. So we are dividing the work in such a way that I don't have to have both the expertise. My work is only to generate the vectors for you.
And that can be done
Is manufactured, yes. So then what happens while you are validating? I'll do some other chip work. I'll start working on some other chip.
These numbers can be generated as soon as we get the specifications. Right?
Yes. Somewhere in that process. Once the design is ready.
Okay, once the design is ready.
Okay. So this is a brief about the technical part of the thing. Okay. So we talked about what is VLSI design flow, what is front end domain, what is back end domain, and we further talked about front end domain having multiple subdomains like architecture, design, integration, verification, and partly DA. Then we talked a little more deep into functional verification. We understood that as a functional verification engineer, our role is to find the bugs. So, I mean, as part of our course also, we'll be focused in that direction. Next, let's get into the other aspects, training schedule and other things. So our training schedule is basically 3 modes are there. One is full week, weekend only mode, weekdays, evening batches. Currently, we don't have this running. If we have some minimum number, we do it. But otherwise, 2 batches are there: full week, weekends. Or you can also go for customized one-to-one training, which is done on an hourly basis. Okay. Next. Full week batch is available both online, offline, and hybrid model. Means what? Hybrid is partly online, partly offline. You can attend
Classes here.
next week. I mean, later you can move to online also. You can switch between online, offline. In all these cases, you have access to the recorded video for 2 weeks for every session. Every session, you have access to the recorded video for 2 weeks. Minimum, generally it is more. Okay. In the weekends only session, it will be live online sessions on Saturday and Sunday. Dedicated mentor will be available. If you want to clarify things in the offline, you want to come to the institute and clarify, you will have a dedicated person to whom you can connect and get your doubts clarified. You have access to all the recorded videos for entire course duration. And next, weekday evening batches is fine. Coming to customized one-to-one training, schedule and session timings are flexible. Course content is flexible. I mean, if it is one-to-one training, you can completely customize what you want to do, all that. In all the modes of training, every student has a dedicated mentor for doubt clarification. So anytime you have a doubt clarification, you can connect with someone in the institute and clarify the doubts. Talking about functional verification training, I told you, right? Functional verification training could mean any of these things. Either you are referring RTL design verification, either I'm referring front-end front-end training for freshers, whether I'm saying design verification course, or everything is same course only. All these things are exactly the same course. Functional verification training will be for 8 months duration. Okay, it will be for 6 days in a week. What we are doing is currently is that out of these 6 days, 5 days we have been teaching our regular things. One day we are keeping it for AI related learning, dedicatedly only. I mean, it starts from the second month onwards. Starting from the second month onwards, we are kind of customizing it where you will be your learning will be customized for AI flow, because our goal is not to make you develop LLM models, right? You know, Claude, you should not be sitting and developing Claude and Gemini. Is it our goal? No. Our goal is to what? Understand, get a bigger level picture. What should be your understanding? That what is the models that are running currently? Tell me what the models are running. Claude, Ola is the wrapper for all of them, right? Then you have got Gemini models, then you have got OpenAI models, right? That understanding you need to have. Then using these models, how to develop custom agents, how to develop custom agent. Custom agent means what? I can develop a verification flow where, for example, AI, I can develop agent. Like, who is agent? The one who will work for me. Look, I don't want to spend all time on work. So I have someone. That someone is the AI agent. So he has limited. He will only do this much. The tokens. Now I can give him instructions. I can use around him, around his abilities. I will develop some Python script, and I can require work. However, that one additional day will be focused on using it on develop AI agents, our own AI agents. Not that we are not going to develop Claude and Gemini. We are going to learn how to use those things, all those parameters will be there, tokens, all and those keywords, and how to set up that entire flow where agents itself will do my work. I will tell to my agent that I want you to read this specification, develop the architecture. It will give me the architecture. I will tell to another agent that okay, this is the architecture. Develop code for it. It will give me the code. Then I'll tell to another agent that this is system code. This is my design. You run the simulation and tell me where our mistakes are there. So that is what we want you to become comfortable eventually, because you don't need to become expert in coding, because anyway coding is pretty much 99% is done by the AI only. So there's no point reinventing the wheel. After 2 years back, it was okay.
Oracle has like removed many.
Yeah.
Many companies are removing
Yeah.
the software development.
Yeah. So 2 years back, yes, what you said is correct. So 2 years back, it was relevant. I mean, discussing a lot of coding, okay, how to do coding, all that. But today it's not relevant. Today, what is relevant? What is the relevant for our discussion? How to use AI agents to do the work for you. So only thing is, it should not be that first time you go to company, there you start doing everything. It's not a very complex thing. Okay, let me tell you. Using AI agents, I mean, you hire someone and making him do the work is not very complex thing. But you just have to get used to it. How to talk to him. That is called as prompt. That is called as prompt. What kind of prompt you will give him? How do you set up the flow? That is what our course will focus on. That one additional day out of these 6 days, We'll focus on how to use Python, what are the different models, what is meant by online model, what is meant by offline models, how to set up the flow where you are able to switch between online model, offline model. What is offline model? I can develop that agents, I mean that LLM into my own laptop without even internet I can start using, but that won't be as efficient as online model. So we'll try to understand all that. What is meant by tokens? What is parameters? How to create a wrapper around all of them, right? So because what we see is going forward, the jobs will be in that direction because companies will expect that your resume will should talk more about that thing. Your resume more than highlighting SVUVM, they should your resume should highlight. I have set up this kind of flow. I'm able to verify the entire thing using AI flow. The companies will expect you to know those things. So our training will also be customized. If you ask me, are we 100% ready with that? No, we are still in the process. We may be 80% close or 90% close. We still have few things to close. For example, debugging we have to do. I can even tell to the agent that this is the mistake. You go and debug and tell me the mistake. It no in our today's flow we don't do, but in the actual companies it tells you a lot of indications. You can check this portion. So we are in that process where we are trying to fix that gap. So once we have that fixed, we will have the entire flow working. Yeah. So even now we'll teach. It's not that we'll wait for 100%. We'll teach that 90% only, because instead of not knowing anything, know enough, right? So by another 2 months, we should be good with the. Okay. So our goal will be finally to make it happen. But we won't ignore SVUVM. Reason is if you go to interview, they need to check something, right? They'll check same thing, digital, Verilog, SVUVM, some protocols. Our regular flow will still teach. Okay. Okay. Now, how this training will work is 6 days a week, 5 hours a day, around 2 hours of theory session, 3 hours of lab session every day. Okay. Like out of these 6 days, only one day will be reserved for other things. I mean, Python, AI related things. Okay. Now, every session recorded video access for minimum 2 weeks. There's a platform like we have a platform where you have access to all these things. All course presentations, assignments, notes are available on this portal, and even printed material will be given to you for all modes. Even if you are attending online, it will be sent to your house by post. In all modes of training, two soft skill training. Regularly going soft skill will be there, because what is important is more than knowing in this AI era, you should be able to talk confidently. You should be able to communicate your thoughts to the other person properly. So that for that we have a dedicated set of trainer, soft skill trainer, who will make sure that uh, he will explain. I mean, he'll help you with everything, starting from how to write your resume, how to attend interviews, how to make a present, how to give a presentation, basic English grammar correction. Right? Sometimes you may have some mistakes in the way you write the things, where you frame a sentence also. That level also of mistakes also will help. It's all about how much you can take from the trainer. Means it's like you soft skill trainer. If you go and ask him to support, he will support to a greater extent. If you just come and go without doing anything, he will also take it casually. So it's all about, that's how institute works basically. Means it's all about how much you want to learn from the institute. Uh, the training is divided into 4 phases. The phase 1 will be phase 2, phase 3, phase 4. Phase 1 will be focused on 2 months of advanced digital design, basics of HTA, text editor, and Verilog language and Verilog projects. This will go for 2.5 months. Phase 2 will be 3 months, which will teach system Verilog and UVM, Linux commands, and from this point onwards, placement support starts. You don't need to wait for 8 months to get the placement support. Placement support starts from the 5 or 6 months. Phase 3 will be 1 month of dedicated interview focused training. Means what happens by the time you reach here, digital design was done 5 months back. Verilog was done 4.5 months back. You'd have lost a lot of forgotten. So we figured that there is such gap always. So we will have 1 month of interview focus training again. Interview focus means what? Again, revision of everything. So once it starts, important questions will be discussed in that. Then we start the last phase, because by this time, since everything is revised, you are ready for job to start, at least apply for the job. From here, the projects will start. Last 2.5 months, multiple industry branded projects. It could be on standard protocols like AXI, AHB, Ethernet, MAC, those kind of projects. And Python scripting, instead of learning here, it will be covered throughout the flow. So we understand that Python is a very important skill now. We don't want to teach in the last week or last 2 weeks. We'll teach continuously. Even today, we have a Python session for regular students. Okay. Some SOC flow basics. And see, phase 1, phase 2 helps in getting a job. Phase 4 is the important one, where you do the actual, this one.
So it will be done like here in the...
Yes, yes. Phase 4. P1 to P3 helps in getting job.
Those green ones needs to be changed. Color needs to be changed.
Okay. The phase 4 helps you perform in the job. This is where our course will be differing from the other institutes, if you ask me. I mean, where does our training differ is, our courses are generally longer. First thing, why they are longer is, many times people who join the courses don't have the required fundamentals. So since we have to teach the fundamentals, it takes time. And actually the main project is where everyone differs. I mean, if you take any other institutions, this part won't be done properly. I told you, your actual skill set is not SVUVM, it's not it's not Verilog. It's actually the project flow is with the actual skill set. If you go to job, even if you don't know much of SVUVM, you can manage actually, but you should be good with debugging. That flow, entire flow, you should be aware. If some issue comes, how to actually reach that issue, how to pinpoint that issue, that you will get only when you do one project, right? You have to do one project. Okay. So this is where our institute will differ from other institutes. Why it will differ? Logical reasoning was, we have sufficient training rooms. We have almost 15 training rooms, so I don't have any restriction that I have to finish this batch in 5 months or 6 months so that I can start a new batch. Most of the other places, they have limited training facility. Let's say 4 rooms you have. Can you run 10 batches or 20 batches with 4 rooms? No. With 15 rooms, I can run 30 batches parallel. Morning one batch, evening one batch. So I don't have any restriction with respect to rooms. And we try to finally, our goal is simple. You should be ready for the job. See, when you go to some company, if someone asks you, don't you know this also, it's like insulting the institute eventually. If you go through a training institute and you don't know very basics also, it's like questioning our ability to teach you. Okay. So I don't want to say too much negative about any other institute, because everyone has their own strength. Okay. In the other institute, smaller projects are done which are not as per the industry requirements. So the problem is, they may do projects, but they don't give you that real debugging feel. Okay. That's where you will see the difference, definitely.
To see the difference, we'll have to experience both, right?
Yes. Yeah.
Right. We'll take your word for it.
Next. Okay. Similarly, experience engineer training also will be similar. Only thing is, they don't have digital and Verilog training. Someone who is already working and uh, okay. So it's like someone is telling, in most P4 is also very important while we attend interview. Even they ask what kind of debugging you have done, what kind of project you have done. So even that phase 4 is also important. Okay. Yeah. So for verification experienced people, it is all same. Only thing is no digital and no Verilog. Yeah. So because of that, the duration will be less for them. And we do UVM more depth for them. For them, UVM course will be done in more depth for experienced people. Okay. Similarly, FPGA, I don't want to go through each of them. We have similar structure. I think the corresponding trainers will explain you. Okay. Now choosing the right course. Only thing I want to tell is, at this point, you should not worry about that I am not good with coding. Okay. Because now we are at a stage where everything is done end-to-end. You just have to get used to how to make the agents do the work for you. So, but still, if you want to get into functional verification, you should have some inclination for programming. You should have that inclination to learn programming and do the things. Uh, Otherwise, if you don't like programming at all, then you can go with backend domain, which can be physical design, which can be DFT, STA, or custom layout. It doesn't require any programming expertise. It is mostly tool and technology focused job. The job nature will be what? Tool and technology oriented focused job. Okay. Uh, Tools means softwares will be there. You have to know how to use the softwares, how to set up the flow, those things. For example, if I give someone this PPT, they will be very good at using different features here and ability to use this tool properly. That kind of expertise you need. Other than that, you need technology basics. How to how does that lower technology work? What is short channel effects? What is antenna effect? What is CMOS latch up? That kind of fundamental semiconductor understanding is required in PD. This is all not required. Sorry, this is not required for a functional verification engineer because he doesn't work at semiconductor level. Institute gives one flexibility where you can join any course and up to 2.5 months you can switch to any other domain. Let's say today you selected functional verification course. After 2.5 months you didn't like it for whatever reason, you can always switch to any other domain without any additional fee.
Initial 1 month is the same.
1 month is anyway same. Is 1 month is common. Whatever remaining 1.5 month or whatever you are missing, you join into the next batch. You join into the upcoming batch. So that way,
like if we are doing 1 month, after 2 months, we think that programming is not our cup of
yes,
tea.
You can always move to the upcoming next batch from the same.
It will be like losing 1 month.
Yes, you will be
For 8 months, it will go
good to 9 months. Yes, kind of. Okay. What is difficult part of the training generally will be, okay, things move quickly actually. Yeah. See, in BTech what happens, your entire course is spread across one semester. Let's say you're doing digital design, network theory, signal system, any topic, it is spread across 4.5 months or 5 months, right? Whatever is the semester duration. Here what happens, at every time one topic is focused, digital design is focused, nothing else is taught. Let's say for next 3 weeks only digital design. Okay, so you have to find interest and so okay, let's talk here. Things move quickly. Let's say for example our 8 months of training, you can correlate with some amount of knowledge you may gain in 2 years of BTech. Okay. Let's say 3 weeks of digital design training, it content will be much more than what you learn in BTech, because our training should not be just for getting 80% or getting 70%, because you have to go to the interview and clear the interview, right? They may ask any kind of tricky question. So our training has to prepare you for all the aspects of digital design. So what do we do? At one extent, we go to all the gate papers, we collect the questions, we try to frame the questions in that direction, we make sure that you become expert in digital design. That entire thing gets over in what? 3 weeks. That's the thing. The 3 weeks is the problem here. If it is 2 months, there's no problem. Okay. Like Verilog. In your BTech course, digital design is spread over one entire semester. You have time to relaxedly study and learn. Okay. So you should learn to complete the things in sync with trainer. So eventually, what is the difficult part here is you have to be motivated throughout that, see, 8 months time. Every time you have to be in sync with the trainer. If you ask me, is it very difficult to do? No.
Have to just
You have to be focused. See, for me it's easy to say, right? If I look from a student perspective, yes, you will have your own challenges, you will have your own problems. So I don't want to say whether it's easy or difficult, but to get job you have to be focused, right? Anytime you lose focus, let's say after 2 months you lose focus and you don't follow, you can stop training. There's no point of continuing training. If you lose focus and you don't prepare, there's no point of continuing, because competition is there. You, to stay in the competition and to get a job, you have to be focused. But if you ask me, okay, I'll put focus, I'll prepare 8 months properly, will I get job? Yes, very good chance that you'll get a job. Why? There's always a need for skilled people. Wherever you go, it's like world is running, the other, except humans, no one else is working, right? Among the people who are good, who are dedicated, who are focused, will always get job. I mean, that has been our observation. Let's say since 14 years or so we have been running the center, right? Training. So sometimes it may get delayed. Instead of 3 months, you may take 6 months, you may take even 9 months also. There are times where, but if you focus and learn, you will eventually get a job. So what is important? Being focused for 8 months, full duration. Where do people really lose the thing is, 1 month they will be focused, or 2 months, after 3 months I don't know where they lose the focus. They stop coming to the batches regularly. They don't attend soft skill training. I, when we are arranging soft skills separately, there is a reason, right? See, for example, where I am talking, my session could have been very boring also. I don't know how is it. It could have been very boring also. Then you want to walk out also. So that means how I convey my thought, my inputs, is also very important, right? As a engineer, you need to know how to do that. That's where we have a dedicated training called as soft skill training, and you never learnt it during BTech. Nobody has taught you, and someone has to teach you at some stage. This is the stage where we are teaching. Now the problem there, what happens, out of 10 people 4 people will come. So though that purpose you have to understand. I mean, if institute is doing something, there has to be some purpose with which we are doing. So let's say today I ask, out of 20 people, tomorrow you prepare a presentation and give presentation to the remaining students. I give you a topic. I ask you to prepare a presentation of 10 slides and give a presentation to the people. Out of 20, how many people will come tomorrow? 4 people or 3 people. That is where the problem comes. You have to come out of that shy factor, that fear factor. You have to learn with passion. Okay, it's not like a motivation lecture. It's like we are trying to tell you, where do people go wrong. You have to utilize the full thing. You have to come out of that. Even after all this, I know still 4 only will come. But tomorrow also, when I ask you to give, because what is the whole point of presentation? The way I am talking comfortably, right? It didn't happen to me day one when I started the institute, and when I started teaching, it didn't happen. Over the time I developed. So we want you to do the same thing over that 6 to 8 months time. You should become so confident that confidence should show to the other person. That is what sells now in the market. Your confidence, how do you talk, how do you, and that doesn't happen without any practice, right? That is what we want you to learn. It's not anymore about SVUVM. It's not anymore about coding. It's about how confidently you can talk. So we have structured all the course in that direction only. But the only problem is, though, many people don't utilize that entire thing. Sometimes they don't attend mock interviews. They don't prepare resume properly at all. Okay, one paper with only what they have done in BTech project. So if you show that kind of problem, there will always be issues. Okay. So in summary, you just have to be in sync with the trainer and complete. So we give one flexibility where anywhere you feel difficulty, we give you option to repeat the course. Let's say digital design you didn't follow in 3 weeks. You can always repeat that course. Okay. How much effort you have to put? just 7 hours a day. Throughout the time, don't even study Sunday, leave Sunday. Remaining all the days, 7 hours in a day, including the time you spend in the institute. You don't need to study 15 hours like UPSC. Okay, 7 to 8 hours in a day, every day. Prepare a proper notes. Just follow the instructions given by institute. If I tell come for soft skill training, you come without miss. If I tell tomorrow you do presentation, you do whatever happens. Even if someone laughs, you still come and do. Tomorrow I tell you you have to attend mock interview, you attend whatever happens, and you try to learn from the mistakes. That if you do regularly, then only you have a job. Anywhere you miss out, your chances becomes less and less, and institute doesn't give any guarantee that will give you 100% job. Institute only trains you in the right direction with the right skill set. Institute connects you with the right opportunities. That's how it works. So I'm not giving you any false promises that will give you 100% job. It all depends upon the market scenario. But from our side, we have a dedicated team which works with the companies to connect all the things and take care of the entire process. Okay. We have a performance tracking where we keep the people into good category, average category, poor performing category. It's not for any discrimination. Okay, it is to provide the required support. Okay, for example, someone is not able to do well at all, so we try to arrange. There are times where we figure out of these 30 people, these 5 people don't know any digital design basics. We try to arrange some dedicated evening sessions for them. There also again motivation. The person should have interest to come in the evening, should sit with the trainer and understand. That's why we do this classification. Performance tracking parameters, assignments is a very important factor. Attendance is a 10%. You attend or no doesn't matter, but finally you should do well. Evaluation test will be there regularly. Presentation you have to give. Student is given a topic, asked to do a presentation. Finally, interviews will be there. Based on this entire thing, we'll have the performance tracking, and there will be a dedicated WhatsApp group for every student. And recently we have been moving to Google Classroom because we have some issues with WhatsApp. I mean, with too many messages, or WhatsApp has been getting blocked. So hence we have been trying to move to Google Classroom, but eventually some communication will be there between you and the trainers. So what is the final goal of this 8 months training is you should be able to work in the job independently. You go to work tomorrow you join into a client project, you should not keep asking to the senior people every small thing. What to do, this line, what to do. That if you do, that's the biggest problem. And again, with AI being your major core skill set, how to do. Okay, it's a collective effort. It's not just institute does it, it's not just you do it. It's a collectively you have to do it. Only thing is, throughout this process you have to be proactive. Means that passion has to drive your learning. You have to think, I have to become a good with AI skills. So even when I started 3 months back, for me also, not a lot of things were new, right? The way fresher can learn, let's say 20-year person can learn, I cannot learn at same speed because I have my own things, right? So but still I have to learn so that I am relevant to the training, right? Otherwise I cannot keep teaching SVUVM and survive next 10 years. I have to teach AI also, right? So I started learning AI also. So that passion also, you have
Learning
to
AI as in using AI?
Using AI, setting up the flow, making AI do the things for you.
It's all about the prompts, right?
Not just the prompts, it's about setting up the using Python script to develop the agents which will do the work for you. It's not a very complex thing.
Okay.
But still, see, for me not
For
complex.
me, yeah.
For you it could still be complex. With time you can learn. Okay, there is so what is the only last 1 minute? Okay, what is the only course prerequisite? You should be good with logical reasoning and quantitative approach. Basic mathematical skills should be there. If I tell into what is 12 into 12, you should not sit for 2 minutes and do the maths. If I ask you what is 12 into 12, you should not take 2-3 minutes to do that multiplication. You should be little quick with some basic numbers, because you may say what is VLSI has to do with 12 into 12. It is there because your brain has to do some it should be logically able to do the analysis and all that. That minimum thing is required. You can always take a test. If you are not ready, if you are scoring very less in the quantitative, you spend 1 month time, don't join the training, spend 1 month, improvise those skill set. This is what is quantitative aptitude. Given some problem, figure out variables, come up with the answer final. That minimum analysis you should be able to do, then only you should join the training. Okay. Yeah. So why to join our institute is our course will be more detailed actually. Course will be more detailed. We may not have done a lot of marketing, but course will be more detailed. We will be addressing your concerns. I mean, not that we are 100% perfect, every day will be perfect. There could always be gaps, but we'll be quick to respond to your gap and fix our things.
So these 8 months, continuous 8 months, or there will be like some specific holidays?
No, national holidays,
National holidays,
Sunday,
Diwali.
only 1 or 2 days for Diwali. It's not like we'll never have 2 week stretch holidays. Break will be based on the student request. Let's say student says that Verilog is done, we need 1 week break, then we go. Student decision will always be considered. Let's say you tell that we have been lot of doing Verilog, we need a break for 1 week, we'll give break. But institute by itself doesn't take break. So that completes the thing. Yeah, I think we'll stop here. Okay. Now we can go over any question and answers, and we'll try to finish as soon as possible. Okay. First question is, can MSc Electronics Science student enroll in this course? Yes, it is possible. If not every company, there are at least 70% of companies consider MSc students. I don't want to tell which company will consider, but there is if you learn the subject properly, there is a good chance that you will be considered. What tools will be? We have all the tools today. Synopsis tools. We have tools for mentor guidance. But majorly we have been teaching synopsis and mentor guidance. We haven't covered so far. But we can teach guidance also, because if you try to teach too many tools, sometimes we lose the focus on other things. But these are good. Synopsis is very good. Will be there for the tools. Uh, this is not just synopsis is company. Synopsis called as yes. Wording. These are the two tools. They have every like version also.
We are subscribed, right?
It's like we go to their website and we go to the most recent one and install. But it doesn't matter whether MS Office is different. What is the STA? See, STA, can you connect with our team? I'll give you our team's number. Please talk to them. That is better, because this specific domain what we are talking is not relevant to STA topic. If you want to get more information about STA, please attend tomorrow's demo session, same time, 9:30. Trainer can help you with all the things. I hope it is clear. Someone with name PV, what all things will be covered. Okay. Next. Is there any test to move to? Yes, there will be. Is there any test or mock interview to move to placement? Yes, it will be there. It is not to, I mean, very deep scrutinize, minimum level knowledge. You go to interview tomorrow, you can't even open your mouth.
Yes.
Right? Should I send you? No. You don't even know the basics of digital design. What is truth table, or what is K-map? What is POS and SOP format? You know, right? Product of sum of product. Or you don't know how to write simple excitation table or D flip flop. Can I send you? So that minimum testing will be done. We are not going to test everything like 100%. Some minimum expertise, because company should not tell this guy doesn't know anything, you are sending, still sending. That minimum testing will be done. But you will still get opportunity. Let's say you didn't do well, you will get opportunity to again attend the mock interviews. Okay. Oh, I'm sorry if my speech was breaking. Actually, what happened? I moved to another room where I connected through my mobile tethering. Let's okay. Anyway, we are continuing. Let's continue for now. But other room I was directly connected to the LAN. Is it possible to before? Is it possible to say about while SVUVM finished interview preparation protocol before interview preparation? No, first we complete. So his question is mostly, can we cover protocol before interview preparation? Generally, we don't do. If you want, you can take protocol e-learning access. Then then join the live training also. Means point is he says, I want to first complete protocol, then go for interview preparation course. If you want, you can do that also. But our thing is what? We want to make sure that you are revising digital, Verilog, SVUVM properly. Then you go to the next set of courses. Okay. Just check. Mostly we are done. Anyway, is my voice still breaking? Those attending online? Is it fine? Okay, fine. Thank you. Okay. Any other questions? Yeah, I think mostly we have addressed. Any other questions? Those attending in classroom. It was a bit lengthy because we tried to go a little deep. Okay. Those attending online, any other questions? So, on concluding note, only one thing I want to tell. Institute will work. I mean, your preparation is driven by your motivation and passion. What is passion? You select one domain. Let's say you selected functional verification as the domain you want to learn. You have to develop that passion for that. See, I'm teaching. I have to somewhere. I have to have the passion to teach. Without that interest, I cannot be doing this job properly. Passion you have to develop. Motivation is what? Whatever motivation you are attending demo today, same motivation should show up on the 8th month, last day of the training. Okay. Once you can maintain that motivation and that passion, 99% chance that you will get a job. Okay, 1% always, there is always uncertainties out there, right? But there's a very good chance that you will get a job. Our course structure will always keep evolving. Evolving means what? We have to change for AI requirements. I mean, whatever is a new thing, we have to change, and we'll do that. We do that. Okay. Though we may not have done a lot of marketing with other things, but we have better capabilities than any other institute in the Bangalore. Okay. So that if you can show that and do that, very good chance that you will get a job. And everything institute tells you have to follow. Soft skill training, mock interviews, presentation, assignments, you have to attend. Okay. And institute tries to put effort to motivate you. Let's say you don't come for presentation. Institute will tell why you didn't come. 2, 3 times they will ask. After fourth time, they'll say let him go to his own thing. That's how institute, right? We are not like your father and mother that every day will keep checking what is happening.
Institute doesn't even ask once you're asking to.
Yeah, so that will always be there because at the end we have that responsibility. But if student itself doesn't want to bother much about his thing, so we stop at that point. Okay. How interview preparation is done? Interview preparation is done in the same manner.
For online
No, again, interview preparation is online also. Though the way I'm teaching, even for interview preparation, I can ask question and answers, right? And I can correct you where you are going wrong, what is going wrong. That entire thing can be done online. It's like interview preparation is something where we have standard set of 100 questions, complex questions in digital design, some 50 to 100 questions in Verilog, some 200, 300 questions in system Verilog. All those things will be discussed, and while making sure that you answer them properly. It's not like making you by heart the things, memorize the things, but giving logical explanation and discussing them.
I think he's thinking of the UPS lens, where 3, 4
Yeah.
set and
It's not like that. No, you can always make a group of 4 or 5 people and discuss. That really worked. I mean, who make a group of 4 or 5 people and prepare collectively, they have better chance of getting job instead of preparing individually. Okay, so we'll stop here. Any other questions? I will be here only if you still have any questions. Again, those attending online, if you still have a question, we can discuss. Otherwise, I'll end the meeting. Okay, fine. Thank you.